Beneath endless waves hides a darkness we barely understand. Deep, cold, waiting. The ocean covers most of our planet, yet it keeps its secrets fiercely guarded. Ships vanish without a trace. Strange sounds echo from unknown depths, baffling scientists. From ghostly vessels drifting aimlessly to the chilling mystery of the Mariana Trench, the ocean's unsolved puzzles haunt our imagination. Recent discoveries only deepen the mystery. Bizarre creatures lurk in utter darkness, life thriving where it shouldn't. Each dive reveals wonders and terrors we can't explain. These mysteries challenge what we think we know about our own world. Perhaps the greatest secrets of the ocean are best left undiscovered. The Bermuda Triangle is a region in the western part of the North Atlantic Ocean where ships and aircraft have allegedly disappeared under mysterious circumstances. This roughly triangular area spans about 500,000 square miles of ocean between the southern coast of Florida, Puerto Rico, and the island of Bermuda. Despite its reputation for unexplained phenomena, the Bermuda Triangle is a heavily traveled shipping lane with frequent air and sea traffic. Many ships and planes pass through the area daily without incident, and the United States Coast Guard does not recognize it as an extraordinarily hazardous zone. The legend of the Bermuda Triangle began to take shape in the 1950s, with reports of ships and planes vanishing without a trace. However, many of these disappearances have been explained by natural phenomena such as violent weather, human error, or equipment failure. Some incidents were later found to have occurred outside the triangle's generally accepted boundaries. Scientific investigations have failed to find any evidence that the area is more dangerous than any other similarly sized region of the ocean. The National Oceanic and Atmospheric Administration states that environmental factors could explain many of the disappearances attributed to the Bermuda Triangle, including the Gulf Stream's swift current and the area's unpredictable weather patterns. The Bermuda Triangle, an area of ocean between Florida, Puerto Rico, and Bermuda, has long captured public imagination with tales of mysterious disappearances. While exact numbers are difficult to pin down due to inconsistent record-keeping and varying definitions of the triangle's boundaries, estimates suggest that several dozen ships and aircraft have vanished in this region over the past century. Some sources claim that more than 50 ships and 20 aircraft have disappeared without a trace in the Bermuda Triangle since 1945. However, these figures are often disputed by skeptics who argue that the number of incidents in this area is not statistically higher than in other busy maritime regions. It's important to note that many of the disappearances attributed to the Bermuda Triangle have logical explanations. Factors such as human error, severe weather conditions, and equipment failure account for a significant portion of these incidents. The area's frequent tropical storms and hurricanes, combined with the Gulf Stream's strong currents, create challenging conditions for navigation. Despite the sensational claims surrounding the Bermuda Triangle, most maritime authorities and scientists do not consider it to be an unusually dangerous area. The majority of ships and aircraft pass through the region without incident, and the rate of disappearances is comparable to other heavily trafficked areas of similar size and conditions. The Bermuda Triangle, an area of the western Atlantic Ocean, has been the site of several notable disappearances that have captured public imagination. One of the most famous incidents occurred in December 1945, when 5 United States Navy bomber planes, known as Flight 19, vanished during a training mission. Despite extensive search efforts, no trace of the aircraft or their 14 crew members was ever found. Another well-known case is the disappearance of the USS Cyclops in March 1918. This massive naval cargo ship, carrying over 300 crew members and passengers, seemingly vanished without a trace while en route from Barbados to Baltimore. It remains one of the largest losses of life in United States naval history, not directly involving combat. The Star Tiger, a British South American Airways airliner, disappeared in January 1948 while flying from the Azores to Bermuda. The aircraft, carrying 6 crew members and 25 passengers, never arrived at its destination. Similarly, in 1949, a sister aircraft called the Star Ariel vanished in the same region while flying from Bermuda to Kingston, Jamaica. These disappearances, along with numerous other incidents involving ships and aircraft, have fueled speculation and mystery surrounding the Bermuda Triangle. While many of these cases remain unsolved, it is important to note that the area experiences heavy maritime and air traffic, and the rate of incidents is not statistically higher than in other busy sea lanes. The Bermuda Triangle, an area of the Western Atlantic Ocean, has long fascinated scientists and the public alike. While many sensational claims surround this region, several scientific theories offer more grounded explanations for the reported anomalies. One prominent theory focuses on methane gas eruptions from the ocean floor. Some geologists suggest that large pockets of methane hydrates beneath the seabed could potentially rupture, releasing vast amounts of gas. This sudden release could significantly reduce water density, causing ships to lose buoyancy and sink rapidly. For aircraft, the theory proposes that such eruptions might create a highly turbulent atmosphere or even ignite, leading to crashes. Another scientific approach examines the unique magnetic properties of the area. Some researchers have noted compass variations and electronic equipment malfunctions in the region. These anomalies might be attributed to the presence of magnetite, a highly magnetic mineral in the surrounding seafloor. Such magnetic irregularities could potentially disrupt navigational systems, leading to disorientation and accidents. Oceanographers and meteorologists also point to the complex interplay of ocean currents and weather patterns in the area. The Gulf Stream, a powerful ocean current, flows through the Bermuda Triangle, creating challenging conditions for seafarers. Combined with the frequent tropical storms and hurricanes in the region, these factors could account for a higher incidence of accidents and disappearances. While these theories offer plausible explanations, ongoing research continues to explore the mysteries of the Bermuda Triangle. The Bermuda Triangle is not the only oceanic region shrouded in mystery and legend. Several other areas around the world have gained notoriety for unexplained phenomena and unusual occurrences. One such area is the Dragon's Triangle, also known as the Devil's Sea, located off the coast of Japan. This region has been associated with numerous ship and aircraft disappearances, leading some to draw parallels with the Bermuda Triangle. Japanese legends speak of dragons and mysterious forces in these waters, adding to its enigmatic reputation. In the North Sea, between Norway and Iceland, lies an area known as the Hector Bank. Sailors have reported bizarre occurrences in this region, including compass malfunctions and electronic equipment failures. Some have even claimed to witness unexplained lights and strange weather patterns in the vicinity. The Great Lakes of North America are home to another mysterious zone called the Michigan Triangle. This area, which stretches from Ludington to Benton Harbor, Michigan, and across to Manitowoc, Wisconsin, has been linked to several ship disappearances and peculiar events. One of the most famous incidents involved the vanishing of Captain George Donner from a locked cabin aboard a ship in 1937. Modern technology has significantly transformed our understanding of the Bermuda Triangle, demystifying many of the long-held beliefs about this infamous region. Advanced satellite imagery and mapping techniques have provided a comprehensive view of the area, revealing underwater topography and ocean currents that were previously unknown. Sophisticated weather monitoring systems now allow scientists to track and analyze atmospheric conditions in real time, offering explanations for many of the unusual phenomena reported in the Triangle. These systems have shown that the region is prone to sudden, intense storms and rogue waves, which could account for some of the historical disappearances and accidents. Improvements in navigation and communication technologies have also played a crucial role. Global positioning systems and advanced radar have made it much easier for ships and aircraft to navigate safely through the area, reducing the number of incidents. Moreover, better communication systems allow for quicker responses to emergencies, potentially saving lives and vessels in distress. Underwater exploration technologies, such as remotely operated vehicles and advanced sonar, have enabled researchers to investigate shipwrecks and debris fields on the ocean floor. These discoveries have provided valuable insights into past incidents, often revealing logical explanations for disappearances that were once shrouded in mystery. As a result, modern technology has largely dispelled the supernatural aura surrounding the Bermuda Triangle, replacing myth with scientific understanding. Human error plays a significant role in many incidents attributed to the Bermuda Triangle. This area, located in the western part of the North Atlantic Ocean, has long been associated with mysterious disappearances of ships and aircraft. However, careful analysis of these incidents often reveals that human mistakes are a primary factor. Navigation errors are a common cause of problems in the Bermuda Triangle. The region's complex ocean currents and frequently changing weather patterns can challenge even experienced pilots and sailors. Misreading instruments, miscalculating fuel needs, or failing to account for sudden weather changes have led to numerous accidents. Equipment failure resulting from human oversight is another contributing factor. Improper maintenance, failure to update navigational charts, or neglecting to check weather forecasts can all lead to dangerous situations. In some cases, overconfidence in technology or underestimating the power of natural forces has resulted in poor decision-making by crew members. Communication breakdowns between vessels and shore stations have also played a part in Bermuda Triangle incidents. Misunderstandings, delayed responses, or failure to report position changes accurately can lead to confusion and potential disaster. While the Bermuda Triangle continues to captivate the public imagination, many experts argue that the rate of incidents in this area is not statistically higher than in other heavily traveled parts of the ocean when human error is taken into account. The Bermuda Triangle, an area of the western Atlantic Ocean, has long captured public imagination with tales of mysterious disappearances. However, contrary to popular belief, there are indeed documented survivors of incidents in this region. One notable case is that of the USS Cyclops, a United States Navy cargo ship that vanished in 1918 with over 300 crew members. While the ship itself was never found, some crew members who had disembarked before its final voyage survived to tell their stories. Their accounts, though inconclusive, have contributed to the ongoing mystery surrounding the ship's fate. In more recent times, numerous pilots and sailors have reported strange occurrences while traversing the Bermuda Triangle, only to emerge safely on the other side. These accounts often involve temporary instrument malfunctions, unusual weather phenomena, or brief periods of disorientation. While these experiences have fueled speculation about the area's purported anomalies, they also demonstrate that many who encounter unusual circumstances in the region do indeed survive. It's important to note that the Bermuda Triangle is a heavily trafficked area for both ships and aircraft, and the vast majority of journeys through the region occur without incident. The documented cases of survivors, combined with routine safe passages, suggest that while the Bermuda Triangle remains a source of fascination, its reputation for danger may be somewhat exaggerated. The Bermuda Triangle, an area in the western part of the North Atlantic Ocean, has long been a subject of fascination and mystery. Despite popular beliefs about supernatural occurrences in this region, its impact on maritime insurance policies has been minimal. Insurance companies base their policies on statistical data and verified incidents rather than unsubstantiated claims or urban legends. The frequency of ship and aircraft disappearances in the Bermuda Triangle is not significantly higher than in other heavily trafficked areas of the ocean when accounting for the volume of traffic passing through the region. Most maritime insurers do not consider the Bermuda Triangle a special risk zone. They treat it like any other area of the ocean, assessing risks based on factors such as weather patterns, shipping routes, and historical accident data. The perception of increased danger in the Bermuda Triangle is largely a product of media sensationalism rather than actual statistical evidence. While some smaller insurance companies might have briefly offered specialized coverage for Bermuda Triangle-related incidents in the past to capitalize on public interest, major insurers have consistently maintained standard policies for vessels traveling through this area. The reality is that modern navigation technology, improved weather forecasting, and advanced safety measures have significantly reduced risks for ships and aircraft in all parts of the world, including the Bermuda Triangle. The Bermuda Triangle has captured the imagination of people worldwide, becoming a fixture in popular culture and media. This mysterious region in the western part of the North Atlantic Ocean has been the subject of countless books, television shows, movies, and documentaries. Many works of fiction have used the Bermuda Triangle as a plot device, often portraying it as a supernatural or extraterrestrial phenomenon. These stories typically feature unexplained disappearances, time warps, or encounters with unknown forces. This has led to a widespread fascination with the area, even among those who are skeptical of its alleged powers. Despite the lack of scientific evidence supporting extraordinary claims about the Bermuda Triangle, its allure persists in the media. Numerous television documentaries have explored the region, attempting to unravel its secrets and explain the various disappearances attributed to it. These programs often blend fact and speculation, further fueling public interest and debate. The Bermuda Triangle has also become a shorthand in popular culture for any mysterious or inexplicable event. Its influence extends beyond direct references, shaping how people think about unexplained phenomena and contributing to a broader cultural fascination with the unknown and the mysterious. The bloop is an ultra-low frequency and extremely powerful underwater sound detected by the United States National Oceanic and Atmospheric Administration in 1997. This mysterious noise was captured by hydrophones, underwater microphones originally designed to detect Soviet submarines spread across the Pacific Ocean. The sound was so loud that it was picked up by multiple sensors over 5,000 kilometers apart. What made the bloop particularly intriguing was its organic nature. Unlike mechanical sounds from submarines or earthquakes, the bloop more closely resembled sounds made by living creatures, but on a vastly larger scale. This led to speculation about massive, unknown sea creatures lurking in the ocean depths. For years, the true source of the bloop remained a subject of debate and mystery. Scientists and the public alike were captivated by the possibility of undiscovered marine life or even mythical creatures like the kraken. However, further research and analysis eventually provided a more grounded explanation. In 2012, NOAA scientists concluded that the bloop was most likely the sound of a large icy quake. These occur when ice shelves break apart, creating massive icebergs. The sound's point of origin coincided with an area known for icequake activity, finally solving the mystery but leaving us with a reminder of the immense forces at work in our oceans. The bloop, detected by underwater microphones in 1997, was one of the loudest underwater sounds ever recorded. It was several times louder than the blue whale, previously considered the loudest animal in the ocean. The bloop was heard by hydrophones located up to 3,000 miles apart, indicating its immense power and reach. To put its volume into perspective, the bloop was louder than a large ship's propellers or even underwater volcanic eruptions. Its sound profile was unlike anything scientists had encountered before, sparking intense speculation about its origin. Some theories suggested it might be produced by an unknown marine animal, while others proposed geological explanations. Interestingly, the sound had characteristics similar to those produced by living creatures, but its sheer volume exceeded that of any known animal. This led to imaginative theories about giant, unknown sea monsters. However, years later, scientists concluded that the sound was likely caused by the cracking of a large Antarctic ice shelf as it broke up. The bloop remains a fascinating example of how mysterious our oceans still are and how sounds can travel vast distances underwater. It reminds us that there is still much to discover about the acoustic landscape of our planet's seas and the phenomena that shape it. The bloop, a powerful ultra-low frequency underwater sound detected in 1997, initially puzzled scientists and sparked numerous theories about its origin. When first discovered, researchers at the National Oceanic and Atmospheric Administration were baffled by its intensity and unique characteristics. The sound was so loud that it was picked up by multiple sensors over 5,000 kilometers apart in the Pacific Ocean. One of the earliest theories proposed that the bloop might be biological in nature. Some scientists speculated that it could be produced by a massive, unknown sea creature, perhaps even larger than a blue whale. This idea captured the public imagination and led to comparisons with mythical sea monsters or undiscovered marine species. Another initial theory suggested that the sound might be related to volcanic or seismic activity on the ocean floor. Underwater earthquakes and volcanic eruptions can produce powerful, low-frequency sounds that travel great distances through water. However, the bloop's unique acoustic signature did not precisely match known geological events, leaving researchers uncertain. Some experts also considered the possibility that the sound could be man-made, potentially originating from a previously unknown type of naval technology or underwater installation. However, the sheer power and unusual characteristics of the bloop made this explanation less likely in the eyes of many scientists. These diverse initial theories highlight the mystery that surrounded the bloop in its early days of discovery. Scientists initially thought the bloop, a mysterious ultra-low frequency sound detected in the Pacific Ocean in 1997, might have been produced by a massive unknown sea creature. However, further investigation revealed a much less exotic explanation. The National Oceanic and Atmospheric Administration conducted extensive research on the bloop and similar sounds. They compared these recordings to those made by large icebergs breaking apart and scraping against each other. The similarities were striking, leading scientists to conclude that the bloop was likely the sound of ice carving in Antarctica. This conclusion was supported by the location of the sound source, which was eventually traced to an area near the Antarctic Peninsula. This region is known for its large ice shelves and frequent carving events. The intensity and low frequency of the sound also matched what would be expected from a massive ice breakup event. While the idea of a giant unknown sea monster captured the public imagination, the scientific process led researchers to a more plausible explanation. The bloop serves as a reminder of how our oceans still hold many mysteries, even if they often have natural rather than supernatural origins. The bloop, a mysterious ultra-low frequency sound detected in the Pacific Ocean in 1997, initially puzzled scientists and sparked wild speculation. Some even suggested it might be evidence of an unknown sea creature. However, the current scientific consensus offers a less sensational but equally fascinating explanation. Researchers now believe the bloop was the sound of a large icequake. These occur when sections of an ice shelf crack and break away from the main body. The sound likely originated from an ice shelf on the coast of Antarctica, possibly in an area known as the Ross Ice Shelf. This conclusion is supported by the similarity between the bloop and other recorded ice shelf sounds. The National Oceanic and Atmospheric Administration has confirmed that the frequency and time duration of the bloop match the profile of ice shelf breaking events. Additionally, the loudness and range of the sound are consistent with the massive scale of Antarctic ice shelves. While this explanation may seem less exciting than the idea of an undiscovered sea monster, it highlights the dynamic nature of our planet's polar regions and the significant impact of climate change on these environments. The bloop serves as a reminder of the ongoing changes in Earth's ice-covered areas and the need for continued scientific study of these remote regions. The bloop is not the only mysterious sound recorded in the depths of our oceans. Several other unexplained underwater noises have puzzled scientists and captured the imagination of the public. One such enigmatic sound is known as Julia, detected in 1999 by the National Oceanic and Atmospheric Administration. Julia was a powerful, low-frequency sound that lasted for about 15 seconds and seemed to originate from the equatorial Pacific Ocean. Another intriguing oceanic sound is called upsweep, first detected in 1991. This sound consists of a series of narrow-band upsweeping sounds, each lasting several seconds. Upsweep has been recorded throughout the Pacific and displays a seasonal pattern, becoming louder during spring and autumn. While its origin remains unknown, some scientists speculate it might be related to volcanic activity. The slowdown is yet another perplexing underwater sound. Recorded in 1997, this noise lasted for about 7 minutes and was characterized by a decreasing frequency. Its source and cause remain a mystery, adding to the list of unexplained phenomena in our vast oceans. These unexplained ocean sounds highlight how much we still have to learn about the underwater world. They remind us that our planet's oceans, covering over 70% of Earth's surface, continue to hold secrets waiting to be unraveled by curious scientists and explorers. Scientists employ a range of sophisticated techniques to distinguish between biological and geological ocean sounds. Biological sounds typically come from marine life such as whales, fish, and crustaceans, while geological sounds originate from natural processes like underwater earthquakes, volcanic eruptions, and ice movements. One key method involves analyzing the frequency and pattern of the sounds. Biological noises often have distinct characteristics, such as the rhythmic patterns of whale songs or the clicking sounds of dolphins. These sounds usually fall within specific frequency ranges that correspond to the vocal abilities of different species. Geological sounds, on the other hand, tend to have different frequency profiles and often lack the regular patterns seen in biological vocalizations. Researchers also consider the duration and intensity of the sounds. Many biological sounds are shorter and more varied, reflecting communication or echolocation behaviors. Geological events like underwater earthquakes often produce longer-lasting, more consistent sounds. Additionally, scientists use advanced sound localization techniques to pinpoint the source of the noise, which can help determine whether it's coming from a moving organism or a fixed geological feature. Context plays a crucial role in sound identification as well. Scientists combine acoustic data with other environmental information, such as water temperature, depth, and known species distributions. This holistic approach allows them to make more accurate determinations about the origins of ocean sounds, continually refining our understanding of the complex acoustic landscape beneath the waves. Scientists employ a range of sophisticated technologies to capture and study enigmatic sounds from the depths of our oceans. Hydrophones, specialized underwater microphones, are the primary tools used to record these elusive noises. These sensitive devices can detect a wide spectrum of frequencies, allowing researchers to capture everything from the low rumbles of seismic activity to the high-pitched calls of marine mammals. To gather data over extended periods, scientists often deploy arrays of hydrophones attached to autonomous underwater vehicles or stationary buoys. These systems can record continuously for months, providing a wealth of acoustic information from various ocean environments. The recorded data is then processed using advanced signal analysis software, which helps isolate specific sounds and filter out background noise. Spectrograms, visual representations of sound frequencies over time, play a crucial role in analyzing these mysterious ocean noises. By examining spectrograms, researchers can identify patterns, compare unknown sounds to known sources, and even track the movements of sound-producing creatures or phenomena. Machine learning algorithms are increasingly being applied to this field, helping to automatically classify and catalog the vast amounts of acoustic data collected. In addition to these recording and analysis techniques, scientists also use other oceanographic instruments alongside acoustic equipment. These may include cameras, environmental sensors, and sonar systems, which provide context and additional data to help explain the origin and nature of mysterious ocean sounds. This multifaceted approach allows researchers to paint a more complete picture of the acoustic landscape beneath the waves. Our understanding of deep-sea acoustics has evolved significantly since the mysterious bloop sound was recorded in 1997. Initially, the bloop puzzled scientists with its powerful, ultra-low frequency sound that was detected by hydrophones across the Pacific Ocean. Many speculated about its origin, with theories ranging from unknown sea creatures to secret military operations. However, advancements in underwater acoustic technology and data analysis have shed new light on such phenomena. We now know that the bloop and similar sounds are likely caused by ice quakes, which occur when large icebergs crack and fracture. This discovery has led to a broader understanding of how sound travels in the ocean and how geological events can create powerful acoustic signatures. Scientists have also developed more sophisticated methods for filtering and interpreting underwater sounds. This has allowed them to distinguish between biological noises, such as whale calls, and geological events with greater accuracy. The improved technology has revealed a rich acoustic landscape in the deep sea, filled with a variety of sounds from marine life, seismic activity, and human-made sources. These advancements have not only solved the mystery of the bloop, but have also opened up new avenues for research. Scientists now use acoustic monitoring to track whale migrations, study the effects of noise pollution on marine life, and even detect underwater volcanic eruptions. This expanded knowledge of deep-sea acoustics continues to provide valuable insights into the hidden world beneath the waves, revolutionizing our understanding of ocean ecosystems and geological processes. The bloop, a mysterious ultra-low frequency sound detected in the Pacific Ocean in 1997, has intriguing implications for our understanding of ocean geology. Initially, the sound's immense volume and unique characteristics puzzled scientists, as it was far louder than any known underwater sound from geological or biological sources. One significant implication of the bloop is the possibility of undiscovered geological processes occurring in the deep ocean. While it was later determined that the sound likely originated from ice calving in Antarctica, the initial mystery surrounding the bloop highlighted our limited knowledge of deep-sea geological activities. This event prompted increased interest in studying underwater seismic events, ice movements, and other geological phenomena that could produce powerful, far-reaching sounds. The bloop also underscored the importance of advanced underwater acoustic monitoring systems in detecting and understanding oceanic events. These systems can potentially provide early warnings for submarine earthquakes, landslides, or other geological hazards that might affect coastal areas. Furthermore, the incident demonstrated how sounds can travel vast distances through the ocean, emphasizing the interconnectedness of marine environments and the potential for geological events in one area to have far-reaching effects. Ultimately, the bloop serves as a reminder that our oceans still hold many secrets. It encourages continued exploration and research into deep-sea geology, pushing us to develop more sophisticated technologies and methodologies for studying the hidden processes shaping our planet beneath the waves. Unidentified submerged objects, or USOs, are mysterious phenomena observed in bodies of water, often described as unexplained lights or solid objects moving beneath the surface. While unidentified flying objects are typically associated with aerial sightings, USOs specifically refer to anomalous occurrences in aquatic environments. USOs have been reported by naval personnel, fishermen, and coastal residents, with accounts describing objects that can move at incredible speeds underwater, change direction abruptly, and even transition between water and air. Unlike UFOs, which are often seen in the sky, USOs present unique challenges for observation and study due to the limitations of underwater visibility and detection technology. The behavior of USOs often defies our understanding of hydrodynamics, with some reports claiming these objects can achieve speeds and maneuvers impossible for known submersibles. This has led to speculation about advanced underwater technologies, unknown marine life, or even extraterrestrial activity beneath the waves. While both UFOs and USOs remain largely unexplained, the study of USOs requires specialized equipment and expertise in marine environments, setting it apart as a distinct field of investigation within the broader realm of unexplained phenomena. Unidentified submerged object sightings, often referred to as USOs, have a long and intriguing history that predates modern UFO encounters. The earliest documented reports of strange underwater phenomena date back to ancient times, with sailors and coastal dwellers describing inexplicable lights and objects beneath the waves. However, the term USO and more systematic reporting of these incidents gained traction in the mid-20th century. During World War II, both Allied and Axis naval forces reported numerous encounters with unexplained underwater objects that demonstrated capabilities far beyond known submarine technology of the time. The 1950s and 60s saw a significant increase in USO reports, coinciding with the rise of UFO sightings and public interest in extraterrestrial phenomena. Notable incidents during this period included the 1957 Sebago case, where the United States Coast Guard cutter Sebago encountered a glowing underwater object in the Gulf of Mexico. While USO sightings continue to be reported to this day, it is important to note that many of these incidents remain unexplained, and scientific investigation into USOs is limited compared to their aerial counterparts. The vast and largely unexplored nature of our oceans leaves ample room for mystery and speculation about the true nature of these submerged anomalies. Unidentified submerged objects, or USOs, have intrigued military personnel and researchers for decades. One of the most credible USO sightings occurred in 1991 off the coast of Brazil. The Brazilian Navy tracked multiple objects moving at incredible speeds underwater, detecting them on sonar and visually observing them emerging from the ocean. Over 100 witnesses, including experienced naval officers, were involved in this incident, which lasted several hours. Another notable case happened in 1966 when the crew of the United States Navy destroyer USS Trepang reported observing and photographing a large, cigar-shaped object emerging from and submerging into the Arctic Ocean. The incident was documented in the ship's log and supported by multiple crew member testimonies. In 2004, the USS Nimitz Carrier Strike Group encountered what they described as a 40-foot-long, white, oblong-shaped object hovering above the water off the coast of California. Fighter pilots reported that the object demonstrated incredible acceleration and maneuverability, both in the air and underwater, far beyond known technological capabilities. These cases stand out due to the credibility of the witnesses, the multiple methods of observation, and the detailed documentation provided. While explanations ranging from secret military technology to extraterrestrial craft have been proposed, these sightings remain unexplained and continue to challenge our understanding of what might exist in the depths of our oceans. Unidentified submerged objects, or USOs, have been reported to move through water in ways that defy our current understanding of hydrodynamics. Witnesses describe these objects traveling at incredible speeds underwater, often without creating the expected turbulence or cavitation bubbles that typically occur when objects move rapidly through liquid. Some accounts suggest that USOs can transition seamlessly between air and water, plunging into the ocean at high velocities without slowing down or showing signs of impact. This behavior puzzles scientists as it seems to violate known principles of fluid dynamics and the enormous pressures objects typically encounter when entering water at speed. Observers have also reported USOs making abrupt changes in direction while submerged, maneuvering in ways that would normally cause extreme G-forces for any occupants. These objects allegedly demonstrate the ability to hover motionless underwater and then accelerate instantaneously, leaving no visible wake or disturbance in the surrounding water. Perhaps most intriguingly, some witnesses claim to have seen USOs surrounded by an unusual glow or bubble-like effect while moving through water. Speculation suggests this could be a form of exotic propulsion or a method of reducing friction, allowing the objects to move more efficiently through the aquatic environment. These reports continue to challenge our understanding of underwater physics and propulsion technologies. Unidentified submersible object sightings, often reported by naval personnel and civilian sailors, show some intriguing patterns across different oceans. The Pacific Ocean, particularly areas near the western coast of North America, has a higher concentration of reported sightings. These objects are frequently described as fast-moving, luminous craft capable of extraordinary maneuvers underwater. The Atlantic Ocean has its share of USO reports, with notable clusters around the Caribbean and the waters off the eastern United States. Interestingly, many of these sightings describe objects transitioning between air and water, suggesting a potential link with unidentified aerial phenomena. In the Indian Ocean, USO reports are less frequent, but often involve larger objects, sometimes described as underwater structures or bases. The Mediterranean Sea, despite its smaller size, has a rich history of USO sightings, many of which date back several decades. While these patterns are intriguing, it is important to note that reporting biases and variations in naval activity across different regions could influence these apparent trends. The true nature and origin of USOs remain a subject of speculation and ongoing investigation by researchers and military organizations worldwide. Unidentified submerged objects, or USOs, have sparked numerous theories about their origin and nature. Some researchers propose these underwater phenomena could be advanced underwater vehicles developed by secret military programs. This theory suggests that governments might possess technology far beyond what is publicly known, capable of extraordinary maneuvers beneath the waves. Another intriguing hypothesis posits that USOs could be evidence of extraterrestrial activity on Earth. Proponents of this idea argue that an alien civilization might find our oceans an ideal place to establish hidden bases, given that much of our planet's surface is covered by water and large portions of the seafloor remain unexplored. Some scientists speculate that USOs might be previously unknown natural phenomena. This could include undiscovered bioluminescent organisms, unusual geological events, or even exotic forms of matter behaving in ways we do not yet understand. The vast, largely unexplored nature of our oceans leaves room for surprising discoveries. A more skeptical perspective suggests that many USO sightings could be misidentifications of known objects or phenomena, such as submarines, large marine animals, or underwater volcanic activity. The distortion of light and sound in water can make familiar things appear strange and mysterious, potentially leading to reports of seemingly inexplicable events. Governments and navies around the world typically approach unidentified submerged object reports with a mix of caution, curiosity, and confidentiality. Many nations have established specialized units or protocols to investigate these underwater anomalies, often integrating them into broader, unidentified aerial phenomena research. Naval forces are usually the first responders to USO incidents, given their presence and expertise in maritime environments. They employ advanced sonar systems, underwater sensors, and specialized equipment to detect and track these objects. However, the challenges of underwater detection and the often fleeting nature of USO encounters make comprehensive investigations difficult. Most governments maintain a policy of secrecy regarding USO reports, citing national security concerns. This approach has led to speculation about the true nature and frequency of these encounters. Some declassified documents have revealed intriguing cases, but many details remain classified. While official responses to USOs are often guarded, there is growing pressure for greater transparency. Some nations have begun to acknowledge the phenomenon more openly, recognizing the potential implications for maritime safety and scientific understanding. As technology advances and public interest grows, the approach to USO reports continues to evolve, balancing security concerns with the pursuit of knowledge about these mysterious underwater phenomena. Unidentified submerged object sightings have intrigued researchers and enthusiasts for decades, and some have speculated about potential connections to other oceanic phenomena. While concrete scientific evidence remains elusive, there are several interesting correlations worth exploring. One notable connection is between USO sightings and bioluminescent events in the ocean. Some witnesses have reported strange lights or glowing objects beneath the water surface, which could be related to bioluminescent organisms like certain species of plankton or jellyfish. These natural light shows can create stunning visual effects that might be mistaken for artificial or otherworldly phenomena. Another correlation exists between USO reports and areas of significant geomagnetic activity, such as underwater volcanic regions or tectonic plate boundaries. These zones often exhibit unusual electromagnetic properties that could potentially interfere with navigation equipment or create visual anomalies. Some researchers speculate that these geomagnetic disturbances might be linked to the appearance of unexplained underwater objects or lights. Interestingly, there seems to be a higher frequency of USO sightings in areas known for their unique oceanographic features, such as deep-sea trenches, underwater canyons, or strong ocean currents. These locations often harbor diverse marine life and complex ecosystems, which could contribute to unusual sightings or acoustic phenomena that might be interpreted as USOs. Unidentified submerged objects, or USOs, have long fascinated both the public and scientific community. While many sightings remain unexplained, advanced technologies could potentially account for some of these mysterious underwater phenomena. One possibility is the use of sophisticated submersible drones. These unmanned underwater vehicles are becoming increasingly advanced, with some capable of diving to extreme depths and maneuvering with remarkable agility. Military organizations around the world are developing such drones for reconnaissance and other purposes, and their unusual appearance or unexpected presence could lead to USO reports. Another technology that might explain some USO sightings is supercavitation. This technique involves creating a bubble of gas around a submerged vessel, dramatically reducing drag and allowing it to travel at extremely high speeds underwater. Torpedoes using this technology can reach speeds of hundreds of kilometers per hour, far faster than conventional submarines. A supercavitating vessel moving at such velocities could appear as a rapidly moving, otherworldly object to observers. Advanced propulsion systems, such as magneto-hydrodynamic drives, could also account for some USO characteristics. These drives use powerful electromagnetic fields to move water around a vessel, potentially allowing for silent operation and unusual maneuverability. Such technology, if successfully implemented, could produce craft capable of the extraordinary speeds and sudden directional changes often reported in USO encounters. The study of unidentified submerged objects, or USOs, has undergone significant changes since its inception. Initially, these underwater phenomena were largely ignored or dismissed as mere folklore. However, as technology advanced and more reliable underwater detection systems were developed, the scientific community began to take a more serious interest in these mysterious occurrences. In the 1950s and 60s, naval forces around the world started reporting unusual sonar contacts and unexplained underwater disturbances. These reports coincided with the rise of UFO sightings, leading some researchers to speculate about a possible connection between aerial and aquatic anomalies. The advent of sophisticated sonar equipment and underwater cameras in recent decades has allowed for more detailed observations and data collection. This has led to a more systematic approach to studying USOs, with researchers analyzing patterns, frequencies, and characteristics of these phenomena. Additionally, the declassification of some government documents has provided new insights into historical USO encounters, allowing for a more comprehensive understanding of their nature and behavior. Today, the study of USOs incorporates a multidisciplinary approach, combining elements of marine biology, oceanography, and even the search for extraterrestrial life. While skepticism remains, the field continues to evolve, driven by new technologies and a growing interest in understanding the mysteries that lie beneath the waves. The Mary Celeste is one of the most enduring maritime mysteries in history. This merchant brigantine was discovered adrift and deserted in the Atlantic Ocean on December 4, 1872. The vessel was found in seaworthy condition with its cargo intact, but its entire crew had vanished without a trace. The Mary Celeste had set sail from New York City on November 7th, bound for Genoa, Italy. On board were Captain Benjamin Briggs, his wife, their young daughter, and a crew of 7. When the ship was found by the British brig Dei Gratia, it was obvious that it had been abandoned in haste. The last log entry was dated 10 days earlier, and a 6-month supply of food and water was still on board. Strangely, the lifeboat was missing, suggesting the crew had left voluntarily. However, their personal belongings and valuables remained untouched. Investigators found no signs of violence, struggle, or foul play. The cargo of industrial alcohol was largely intact, though 9 barrels were empty. Over the years, numerous theories have been proposed to explain the crew's disappearance, ranging from piracy and mutiny to supernatural events. More plausible explanations include the possibility of an explosion caused by alcohol fumes, prompting a panicked evacuation, or severe weather, causing the crew to abandon ship unnecessarily. Despite extensive investigations, the true fate of the Mary Celeste's crew remains unknown, cementing its place in maritime lore. The Mary Celeste, a merchant brigantine, was discovered adrift and deserted in the Atlantic Ocean on December 5, 1872. The ship was found by the crew of another vessel, the Dei Gratia, about 400 nautical miles east of the Azores Islands. When the Dei Gratia's crew boarded the Mary Celeste, they found the ship in seaworthy condition, with ample provisions and valuable cargo still intact. However, there was no sign of the captain, his family, or the crew. The last entry in the ship's log was dated 10 days earlier, on November 25th. The discovery of the abandoned Mary Celeste sparked one of the most enduring maritime mysteries. Investigators found no signs of violence or struggle aboard the vessel. The ship's only lifeboat was missing, suggesting that the crew had left voluntarily, but the reason for their departure remains unknown to this day. This puzzling incident has fueled speculation and theories for over a century, ranging from piracy and mutiny to more far-fetched explanations involving sea monsters or alien abductions. The Mary Celeste continues to captivate the public imagination, serving as a reminder of the vast ocean's capacity to keep secrets. The ship, when discovered, was in a remarkably well-preserved state, considering its long submersion in the cold, dark depths of the Atlantic Ocean. Resting upright on the seafloor at a depth of about 12,000 feet, the Titanic had split into two main sections, the bow and the stern. These sections lay approximately 2,000 feet apart, with a debris field scattered between them. The bow section, which plunged into the seabed nose first, remained relatively intact. Its structure was better preserved due to the more gradual way it sank and settled on the ocean floor. The stern section, however, had suffered more extensive damage. It had imploded during its rapid descent, leaving it in a more deteriorated state, with its decks collapsed and interiors largely destroyed. Despite the damage, many features of the ship were still recognizable. The grand staircase, though no longer present, left a distinctive void where it once stood. Chandeliers still hung in some of the better-preserved rooms, and personal belongings of passengers were strewn across the debris field, offering poignant reminders of the human tragedy. The discovery revealed that the Titanic was slowly deteriorating due to natural processes and the actions of metal-eating bacteria. Rusticles, formations of rust created by these bacteria, adorned much of the ship's exterior, giving it the appearance of reddish-brown icicles frozen in time beneath the waves. The mysterious disappearance of the Mary Celeste's crew has puzzled maritime historians for over a century. Several theories attempt to explain their fate, each with its own merits and shortcomings. One prominent theory suggests that the crew abandoned ship due to fears of an explosion. Investigators found the main hatch open and detected traces of alcohol in the cargo hold, leading some to speculate that alcohol fumes might have alarmed the crew, prompting them to leave the vessel in a panic. Another theory proposes that the Mary Celeste encountered a waterspout or seaquake, causing the crew to abandon ship out of fear. This explanation accounts for the vessel's disheveled state upon discovery, but fails to explain why no distress signals were sent. Some researchers have suggested that pirates might have attacked the ship, forcing the crew to leave. However, the lack of signs of violence or theft on board casts doubt on this hypothesis. A more unconventional theory posits that the crew fell victim to a sudden release of poisonous gases from the cargo hold. This could explain their rapid departure, but does not account for why their bodies were never found. Lastly, some speculate that the crew might have been swept overboard by a rogue wave, though this scenario seems unlikely given the calm weather conditions reported in the area at the time. Despite numerous investigations and theories, the true fate of the Mary Celeste's crew remains a maritime mystery. The lack of concrete evidence and eyewitness accounts continues to fuel speculation and debate among historians and enthusiasts alike. The Mary Celeste mystery has become a cornerstone of maritime folklore, captivating the imagination of sailors and landlubbers alike for over a century. This merchant brigantine was discovered adrift and deserted in the Atlantic Ocean in 1872, spawning countless theories and tales of supernatural occurrences at sea. The peculiar circumstances surrounding the Mary Celeste have significantly shaped our perception of maritime dangers. The ship was found in seaworthy condition, with its cargo intact and the crew's personal belongings undisturbed, yet not a soul was on board. This inexplicable abandonment has fueled speculation about the perils lurking in the vast oceans, from sea monsters to alien abductions. The Mary Celeste incident has also influenced literature and popular culture, inspiring numerous books, films, and television shows. Sir Arthur Conan Doyle, creator of Sherlock Holmes, wrote a short story loosely based on the event, further cementing its place in the public consciousness. This enduring mystery has become a symbol for unexplained disappearances and the unpredictable nature of life at sea. Moreover, the Mary Celeste has contributed to the romanticization of seafaring and exploration. It represents the allure of unsolved maritime puzzles and the enduring human fascination with the unknown. The story continues to intrigue modern audiences, serving as a reminder of the ocean's vast, untamed nature and the mysteries that still exist in our world despite technological advancements. The Mary Celeste, a merchant brigantine found adrift and deserted in the Atlantic Ocean in 1872, continues to captivate our imagination with its enduring mystery. Several clues were indeed discovered aboard the ship, but they only deepened the enigma surrounding its abandonment. When the vessel was boarded, investigators found that the cargo of denatured alcohol was largely intact, and the crew's personal belongings were undisturbed. This suggested that whatever caused the crew to leave happened suddenly, without time for extensive preparation. A single missing lifeboat indicated a deliberate departure rather than a catastrophic event that might have swept the crew overboard. One of the most puzzling clues was the state of the ship itself. The Mary Celeste was found to be seaworthy, with only minor damage and some water in the hold. This water, however, was not nearly enough to threaten the vessel's safety, making it unclear why the crew would have abandoned a functioning ship. The ship's log, found on board, contained entries up to 9 days before the vessel was discovered, but offered no explanation for the crew's disappearance. Another intriguing detail was the presence of a 6-month supply of food and water, ruling out the possibility that the crew had left due to a shortage of provisions. These clues, while tantalizing, have never provided a definitive answer to what transpired on the Mary Celeste, leaving us with a maritime mystery that continues to spark debate and speculation to this day. The Mary Celeste mystery has intrigued researchers for over a century, and modern forensic techniques have shed new light on this enigmatic case. One significant advancement has been the use of computer simulations to recreate the weather conditions and ocean currents at the time of the ship's abandonment. These simulations have helped experts better understand the vessel's likely path and the environmental factors that may have influenced the crew's decisions. Chemical analysis techniques have also been applied to preserved samples from the Mary Celeste. Researchers have examined traces of substances found in the ship's cargo holds, seeking evidence of potentially dangerous chemical reactions or explosions. This analysis has helped rule out some theories while lending support to others, such as the possibility of alcohol fumes from the cargo creating a potentially explosive atmosphere. Forensic psychologists have contributed to the investigation by analyzing historical records and crew profiles. They have attempted to reconstruct the mental state and decision-making processes of Captain Benjamin Briggs and his crew, considering factors such as stress, fatigue, and the isolated nature of their voyage. This psychological approach has offered new perspectives on why the crew might have abandoned a seaworthy vessel. Advanced imaging technologies have been used to examine contemporary photographs and documents related to the Mary Celeste. These techniques have revealed previously unnoticed details and have helped authenticate or discredit various pieces of evidence. While modern forensics have not definitively solved the mystery, they have certainly narrowed down the possibilities and provided a more scientific framework for understanding this enduring maritime puzzle. The Mary Celeste is not the only ghost ship to have captured public imagination. Several other vessels have been found adrift or abandoned under mysterious circumstances, leaving behind puzzling questions and intriguing stories. One notable example is the Carroll A. Deering, a 5-masted schooner discovered run aground off the coast of North Carolina in 1921. The ship was intact, but its entire crew had vanished without a trace. Food was found prepared in the galley, and personal belongings were left behind, much like the Mary Celeste case. Another fascinating incident involves the SS Bachimo, a cargo steamer abandoned in the Arctic Ocean in 1931. Remarkably, this ghost ship was spotted multiple times over the next several decades, floating unmanned through the icy waters. The last confirmed sighting was in 1969, nearly 40 years after its abandonment. The Joyita, a merchant vessel found adrift in the South Pacific in 1955, presents another perplexing case. The ship was discovered with no sign of its 25 passengers and crew, despite having plenty of supplies and a functioning radio. These ghost ship incidents continue to intrigue maritime enthusiasts and challenge our understanding of the mysteries that can unfold at sea. The mysterious tale of the Mary Celeste has captivated storytellers and audiences for generations, inspiring numerous works of literature and film. This merchant ship, found abandoned in the Atlantic Ocean in 1872, has become a cornerstone of maritime lore and a popular subject for creative interpretation. In literature, the Mary Celeste has been featured in both fiction and non-fiction works. One of the earliest and most influential accounts was a short story by Sir Arthur Conan Doyle, creator of Sherlock Holmes. His 1884 tale, J. Habakkuk Jeffson's statement, though largely fictitious, helped cement the Mary Celeste in the public imagination. Since then, countless novels, short stories, and poems have explored the ship's fate, often blending historical facts with supernatural elements or elaborate conspiracy theories. The silver screen has also embraced the Mary Celeste enigma. Numerous documentaries have attempted to unravel the mystery, presenting various theories and expert analyses. In the realm of fiction, the ship has appeared in several films and television episodes, ranging from serious historical dramas to science fiction adventures. These adaptations often take creative liberties, introducing elements like alien abductions, time travel, or government cover-ups to explain the crew's disappearance. Across both literature and film, the Mary Celeste story continues to evolve, reflecting changing cultural interests and storytelling techniques. While some works strive for historical accuracy, others use the ship's mystery as a springboard for imaginative tales, ensuring that this maritime enigma remains a source of fascination and speculation for audiences worldwide. The Mary Celeste incident has left an indelible mark on maritime history, prompting significant changes in seafaring practices and safety protocols. One of the key lessons learned was the importance of thorough documentation and record-keeping aboard vessels. The mysterious circumstances surrounding the Mary Celeste highlighted the need for detailed logs and regular communication with shore, which are now standard practices in modern shipping. The incident also led to improvements in ship security and crew training. Maritime authorities recognized the need for better preparedness in handling unexpected situations at sea. This resulted in more comprehensive emergency procedures and drills being implemented across the industry. Crew members are now trained to respond to a wide range of scenarios, from severe weather to potential security threats. Furthermore, the Mary Celeste case underscored the significance of proper cargo handling and storage. Speculation about the role of the alcohol cargo in the crew's disappearance led to stricter regulations on the transportation of hazardous materials. Today, there are detailed guidelines and safety measures for carrying various types of cargo, especially those that could pose risks to the ship and its crew. Lastly, the enduring mystery of the Mary Celeste has taught the maritime community the value of thorough investigations and the importance of preserving evidence in unusual incidents. This has led to the development of more sophisticated forensic techniques and investigative procedures in maritime accidents and disappearances, ensuring that modern-day incidents can be more effectively analyzed and understood. Among the most captivating underwater ruins discovered are the remnants of ancient civilizations that now lie beneath the waves. The lost city of Pavlopetri off the coast of Greece stands out as one of the oldest submerged urban settlements, dating back approximately 5,000 years. This Mycenaean-era town provides archaeologists with invaluable insights into ancient Greek life and urban planning. In the waters off Alexandria, Egypt, divers have explored the sunken palace complex of Cleopatra, which includes sphinxes, statues, and architectural elements from the Ptolemaic period. These ruins offer a glimpse into the opulent world of ancient Egyptian royalty and the historical events that led to their submergence. The underwater city of Port Royal in Jamaica tells a different story. Once known as the wickedest city on Earth, this 17th-century pirate haven sank into the Caribbean Sea following a catastrophic earthquake in 1692. Its well-preserved ruins provide a unique time capsule of colonial-era life and maritime history. In the waters of Yonaguni, Japan, a series of massive stone structures have sparked debate among researchers. Some argue these formations are the remains of an ancient civilization, while others contend they are naturally occurring geological features. Regardless of their origin, the Yonaguni monument continues to intrigue scientists and history enthusiasts alike, highlighting the ongoing mysteries that lie beneath the ocean's surface. Underwater, archaeologists employ a range of techniques to differentiate between natural formations and structures created by humans. They begin by studying the overall shape and layout of underwater features. Human-made structures often exhibit regular geometric patterns, straight lines, or symmetrical designs that are uncommon in nature. These might include the remnants of walls, foundations, or deliberate arrangements of stones. Archaeologists also examine the materials present at a site. If they find materials that are not native to the area or that show signs of manipulation, such as cut stones or worked timber, this suggests human activity. The presence of artifacts like pottery, tools, or other objects clearly made by humans provides strong evidence of a man-made site. Advanced technology plays a crucial role in underwater archaeology. Sonar mapping can reveal the outlines of submerged structures, while magnetometers detect metal objects buried beneath sediment. Remotely operated vehicles equipped with high-resolution cameras allow archaeologists to examine sites in detail without the need for divers. Context is also vital in identifying man-made structures. Archaeologists consider the site's location, its relationship to known historical settlements or trade routes, and its depth relative to past sea levels. By combining these various methods and pieces of evidence, underwater archaeologists can confidently distinguish between natural formations and the remnants of human activity hidden beneath the waves. Researchers exploring underwater ruins encounter numerous challenges that test their skills and technology. The aquatic environment itself poses significant obstacles, with water pressure increasing dramatically as divers descend to greater depths. This limits the time they can spend investigating sites and requires specialized equipment to withstand the crushing force. Visibility is another major hurdle, as murky waters and stirred-up sediment can reduce sight to mere inches. Archaeologists often rely on advanced sonar and imaging technologies to map sites, but these tools have limitations and cannot replace the keen eye of a trained observer. The corrosive nature of saltwater rapidly degrades many materials, making the preservation and recovery of artifacts a race against time. Researchers must carefully document and sometimes treat objects on site to prevent further deterioration. Additionally, marine life can pose risks to both divers and ruins, with some creatures making their homes in ancient structures or potentially mistaking equipment for prey. Logistical challenges abound as well. Transporting necessary equipment to remote locations, maintaining communication between surface teams and divers, and ensuring the safety of personnel in an inherently dangerous environment all require meticulous planning and execution. Despite these obstacles, underwater archaeologists continue to uncover fascinating insights into our past, driven by the allure of discovery and the importance of preserving our submerged cultural heritage. Technological advancements have revolutionized our ability to explore and study submerged cities, opening up a whole new world beneath the waves. Sonar systems have become increasingly sophisticated, allowing archaeologists to create detailed maps of underwater landscapes without even diving. These high-resolution images reveal structures and artifacts that were previously hidden from view, guiding researchers to the most promising sites for further investigation. Remotely operated vehicles, or ROVs, equipped with high-definition cameras and robotic arms, have become invaluable tools in underwater archaeology. These machines can descend to depths far beyond the reach of human divers, capturing images and even collecting samples from ancient ruins on the seafloor. This technology enables scientists to study submerged cities in unprecedented detail while minimizing the risks associated with deep-sea exploration. Advancements in underwater photography and videography have also played a crucial role. Specialized cameras and lighting systems can now capture stunning images in the murky depths, revealing intricate details of submerged structures and artifacts. These visual records are essential for documentation and analysis, allowing researchers to study sites long after leaving the water. Perhaps most excitingly, three-dimensional modeling technology has made it possible to create virtual reconstructions of submerged cities. By combining data from sonar scans, photogrammetry, and other sources, archaeologists can build detailed digital models of underwater sites. These models not only help in visualizing and studying the cities, but also in sharing discoveries with the public, bringing these hidden wonders to life for everyone to explore. The Yonaguni Monument, located off the coast of Japan, has sparked intense debate among scientists and researchers. Some experts believe these underwater structures are the remnants of an ancient civilization, possibly dating back thousands of years. They point to the seemingly regular shapes and apparent right angles as evidence of human construction. Proponents of this theory suggest that rising sea levels at the end of the last ice age submerged these structures, preserving them beneath the waves. However, many geologists argue that the Yonaguni Monument is a natural formation. They explain that the sandstone layers of the seabed can fracture along plains, creating geometric patterns that resemble artificial structures. These scientists contend that millions of years of erosion by waves, currents, and earthquakes have shaped the rocks into their current form. A third perspective combines these views, proposing that while the Yonaguni Monument might have a natural origin, ancient humans could have modified and enhanced the existing formations. This theory suggests that people recognized the unique shapes and adapted them for ceremonial or practical purposes before rising seas claimed the area. Regardless of its origin, the Yonaguni Monument continues to captivate researchers and the public alike. Its enigmatic nature serves as a reminder of how much we have yet to discover about our planet's past and the countless mysteries that lie hidden beneath the ocean's surface. Rising sea levels are reshaping our understanding of ancient coastal civilizations in profound ways. As oceans creep higher, they reveal long-hidden archaeological sites and submerged landscapes that were once home to thriving communities. These discoveries are forcing archaeologists and historians to rewrite the narratives of human coastal habitation and migration. Many ancient settlements were built near coastlines for easy access to marine resources and trade routes. However, the end of the last ice age triggered a significant rise in sea levels, inundating vast stretches of coastal land. This means that a wealth of archaeological evidence now lies beneath the waves, waiting to be uncovered. Advanced underwater archaeology techniques are allowing researchers to explore these submerged sites, unveiling cities, ports, and entire landscapes that have been hidden for thousands of years. For example, off the coast of Egypt, the ancient cities of Thonis Heracleion and Canopus have been discovered, offering new insights into the maritime history of ancient Egypt and its connections to the Mediterranean world. These underwater discoveries are not only expanding our knowledge of specific civilizations, but also changing our understanding of human adaptation to changing environments. They provide valuable clues about how past societies responded to rising seas, informing our approach to similar challenges today. As sea levels continue to rise due to climate change, the lessons from these ancient coastal civilizations become increasingly relevant to our modern world. Local legends have played a crucial role in the discovery of underwater ruins throughout history. These oral traditions, passed down through generations, often contain kernels of truth that have led archaeologists and explorers to remarkable finds beneath the waves. In many coastal communities, stories of sunken cities or lost treasures have persisted for centuries. While some might dismiss these tales as mere folklore, researchers have learned to pay attention to these narratives, recognizing them as potential clues to hidden archaeological sites. These legends often provide valuable information about the location, nature, and historical context of submerged structures. One notable example is the discovery of the ancient Egyptian city of Heracleion. Local fishermen had long spoken of ruins beneath the waters of Abu Qir Bay. But it wasn't until the year 2000 that archaeologists finally located the lost city. The legends had preserved the memory of this once thriving port, submerged for over 1,000 years. Similarly, in Japan, local tales of underwater structures off the coast of Yonaguni Island led to the discovery of the Yonaguni Monument. While debate continues about whether these formations are natural or man-made, the local legends were instrumental in drawing attention to this intriguing site. These examples demonstrate how local knowledge, preserved through storytelling, can guide modern scientific exploration and uncover hidden chapters of our past. Underwater archaeology has indeed revealed several intriguing sites that have forced scientists to reconsider aspects of human history. One such location is the submerged city of Pavlopetri off the coast of southern Greece. This Bronze Age settlement, dating back approximately 5,000 years, provides unprecedented insights into urban planning and maritime trade in the ancient Mediterranean. In the Gulf of Cambay off the western coast of India, researchers have discovered a vast complex of structures lying 40 meters below the surface. Some experts believe these ruins could be over 9,000 years old, potentially predating the oldest known civilizations in the region by thousands of years. However, the age and nature of these structures remain subjects of ongoing debate and investigation. Perhaps the most famous underwater site challenging historical narratives is the Yonaguni Monument near Japan. This massive underwater rock formation features sharp edges, flat surfaces, and what appear to be stairs and terraces. While some researchers argue it is a natural formation, others believe it could be the remnants of an ancient civilization, possibly dating back 10,000 years or more. These underwater discoveries continue to spark debate and fuel new research. As technology advances and we explore more of our ocean floors, we may uncover further evidence that reshapes our understanding of human history and the rise of early civilizations. Researchers employ several sophisticated techniques to date underwater structures and artifacts. One common method is radiocarbon dating, which measures the decay of carbon-14 isotopes in organic materials. This approach works well for wooden shipwrecks, leather goods, and other items of biological origin found beneath the waves. For inorganic materials like stone structures or metal objects, scientists often turn to other methods. Thermoluminescence dating can determine when certain minerals were last exposed to sunlight or heat, making it useful for ceramics and some types of rock. Archaeologists also use optically stimulated luminescence, which measures the last time quartz or feldspar grains were exposed to light. In some cases, researchers analyze the buildup of mineral deposits on submerged objects. By studying the layers of marine growth, they can estimate how long an item has been underwater. This technique is particularly useful for dating shipwrecks and sunken cities. Contextual analysis also plays a crucial role in underwater archaeology. By examining the style, construction techniques, and materials of artifacts, experts can often place them within a specific historical period. This method, combined with more precise scientific dating techniques, helps create a comprehensive understanding of underwater sites and their place in history. Underwater ruins offer a fascinating window into our planet's past, revealing crucial information about ancient sea levels and climate change. These submerged structures, once part of thriving coastal communities, now lie hidden beneath the waves, preserving a record of environmental shifts over thousands of years. By studying the depth and location of underwater ruins, scientists can reconstruct historical sea levels with remarkable accuracy. For instance, the sunken city of Pavlopetri off the coast of Greece lies about 4 meters below the current sea level, indicating a significant rise in water levels since its abandonment around 1100 BCE. This information helps researchers track the pace of sea level change over millennia, providing valuable context for understanding modern climate trends. Underwater ruins also offer insights into past climate patterns and their effects on human societies. The presence of certain architectural features or artifacts can indicate the climate conditions that prevailed when these settlements were active. For example, the discovery of ancient harbors now submerged, far from the current coastline, suggests periods of lower sea levels, possibly linked to cooler global temperatures. Moreover, the state of preservation of underwater ruins can tell us about the rate and nature of sea level rise. Gradual submergence tends to leave structures more intact, while rapid flooding can cause more damage. This information helps scientists distinguish between slow, natural climate fluctuations and more abrupt changes that might have been triggered by events such as glacial melting or tectonic activity. The kraken is a legendary sea monster from Scandinavian folklore, a colossal creature said to dwell in the deep waters off the coasts of Norway and Greenland. Described as a giant squid or octopus-like beast, the kraken was believed to be so enormous that it could be mistaken for an island when floating at the surface. According to tales passed down through generations of sailors, the kraken would suddenly emerge from the depths, wrapping its massive tentacles around ships and dragging them down to the ocean floor. These stories often depicted the monster creating whirlpools as it descended, further endangering any nearby vessels. The legend of the kraken grew in popularity during the 18th century, appearing in scientific texts and literature. While modern science has debunked the existence of such a massive creature, the myth likely originated from sightings of real giant squid, which can grow up to 43 feet in length. Today, the kraken remains a popular figure in popular culture, appearing in movies, books, and games. Its enduring legacy speaks to our fascination with the mysteries of the deep ocean and the creatures that might lurk in its unexplored regions. The kraken, a legendary sea monster of enormous size and fearsome appearance, has cast a long shadow over maritime culture for centuries. This mythical creature, often described as a giant squid or octopus-like beast, captured the imagination of sailors and coastal communities alike, shaping their beliefs, practices, and folklore. In Scandinavian waters, where the kraken legend originated, fishermen both feared and revered the creature. They believed the kraken could drag entire ships to the depths, leading to the development of specific sailing routes and fishing practices designed to avoid areas associated with kraken sightings. Interestingly, some sailors also saw potential benefits in the kraken's presence, believing that waters churned by the monster would bring fish to the surface, resulting in bountiful catches. The kraken myth influenced nautical charts and maps, with cartographers often depicting sea monsters in unexplored areas of the ocean. These illustrations served as warnings to sailors, representing the unknown dangers that lurked in distant waters. The creature's fearsome reputation also inspired numerous maritime superstitions and rituals, with sailors performing specific actions or carrying talismans to ward off the monster's attention. Beyond practical influences, the kraken became a powerful symbol in maritime literature and art. From ancient Norse sagas to more recent works like Alfred Tennyson's poem The Kraken and its appearances in popular culture, this mythical beast has continued to captivate audiences, representing the mysteries and dangers of the deep sea. The enduring legacy of the kraken myth underscores humanity's complex relationship with the ocean, blending fear, respect, and fascination for the unknown depths. The giant squid, a creature that has captivated human imagination for centuries, was first scientifically documented in 1857. Danish naturalist Japetus Steenstrup made this groundbreaking discovery, examining parts of a giant squid that had washed ashore in Denmark. Before this official documentation, tales of enormous sea monsters had circulated among sailors and coastal communities for generations. These stories often described massive, tentacled creatures capable of dragging ships beneath the waves. While many dismissed these accounts as mere folklore, Steenstrup's work provided the first concrete evidence that such large cephalopods actually existed. Steenstrup's findings sparked intense scientific interest in these elusive deep-sea dwellers. However, it would be nearly 150 years before researchers managed to capture footage of a live giant squid in its natural habitat. This momentous event occurred in 2004 when Japanese scientists successfully filmed a giant squid at a depth of about 900 meters in the Pacific Ocean. The journey from myth to scientific fact highlights the challenges of studying deep-sea creatures. The giant squid's preference for extreme depths makes direct observation extremely difficult, requiring advanced technology and persistent effort from marine biologists and oceanographers to unravel its mysteries. Giant squid are truly remarkable creatures that capture our imagination with their enormous size. These elusive denizens of the deep can grow to astonishing proportions, reaching lengths of up to 40 to 50 feet from the tip of their mantle to the ends of their longest tentacles. To put this into perspective, that is about the length of a school bus or a semi-trailer truck. The body or mantle of a giant squid typically measures around 6 to 7 feet long, while their arms and tentacles make up the majority of their impressive length. These cephalopods possess 8 arms and 2 longer feeding tentacles, which they use to capture prey in the dark depths of the ocean. Interestingly, female giant squid tend to be larger than males, a characteristic known as sexual dimorphism. The largest reliably measured specimen was a female that washed ashore on a beach in New Zealand. It had a mantle length of over 11 feet and a total length of 43 feet, showcasing the awe-inspiring size these creatures can attain. While there are historical claims of even larger specimens, reaching up to 60 feet or more, these reports are often considered exaggerations or misidentifications. Nevertheless, the confirmed sizes of giant squid are still impressive enough to solidify their status as one of the largest known invertebrates in the world, rivaled only by the colossal squid of the Antarctic waters. Researchers studying giant squid encounter numerous obstacles due to the elusive nature of these deep-sea creatures. The primary challenge is the extreme depth at which giant squid live, typically between 1,000 and 3,000 feet below the ocean surface. This environment is difficult and expensive for scientists to access, requiring specialized equipment and vessels. The darkness of the deep ocean further complicates observation efforts. Giant squid have rarely been seen in their natural habitat, making it challenging to study their behavior and ecology. Most of our knowledge comes from dead specimens that have washed ashore or been found in the stomachs of sperm whales, their primary predator. Another hurdle is the fragility of giant squid bodies. Their soft tissues deteriorate quickly when brought to the surface, making it hard to preserve specimens for detailed study. This rapid decomposition also means that many physical characteristics and internal structures are poorly understood. The vast expanse of the ocean adds to the difficulty of locating giant squid. Their population size and distribution remain largely unknown, making targeted research expeditions a significant challenge. These factors combined have made the giant squid one of the most mysterious and least understood large animals on Earth, despite its iconic status in marine biology. Giant squid, the elusive denizens of the deep ocean, have long captured our imagination and may have inspired tales of the legendary kraken. These real-life cephalopods can grow to impressive sizes, with the largest confirmed specimen measuring about 43 feet in length. However, they fall short of the monstrous proportions attributed to the mythical kraken. The kraken of Norse mythology was described as a beast so enormous it could be mistaken for an island. According to legend, this colossal creature could easily envelop and sink entire ships with its tentacles. While giant squid are formidable predators, they lack the ship-destroying capabilities of their mythical counterpart. Interestingly, the behavior of giant squid might have contributed to the kraken myth. These deep-sea dwellers occasionally wash up on shores or float on the ocean's surface after death, potentially fueling stories of sea monsters. Additionally, their method of hunting, using long tentacles to snare prey, could have inspired tales of ships being dragged underwater. Despite the differences in size and power, the connection between giant squid and the kraken highlights how real animals can inspire legendary creatures. As we continue to explore the ocean depths, we uncover more about these fascinating creatures, separating fact from fiction while maintaining a sense of wonder about the mysteries that still lurk in the vast, unexplored regions of our oceans. Scientists employ a variety of innovative techniques to search for and study the elusive giant squid. Deep-sea submersibles equipped with high-definition cameras allow researchers to explore the dark depths where these mysterious creatures dwell. These unmanned vehicles can descend to extreme depths, capturing rare footage of giant squid in their natural habitat. Sonar technology plays a crucial role in detecting large objects in the water column, potentially indicating the presence of giant squid. Researchers analyze these acoustic signals to track movement patterns and estimate the size of these enigmatic cephalopods. Additionally, environmental DNA sampling has become an invaluable tool. By collecting and analyzing water samples for traces of giant squid DNA, scientists can confirm their presence in specific areas without direct observation. Tissue sampling from beached specimens or rare captures provides vital genetic information, helping researchers understand the population structure and evolutionary history of giant squid. Scientists also study the stomach contents of sperm whales, known predators of giant squid, to gain insights into their diet, distribution, and behavior. Collaborative efforts between marine biologists, oceanographers, and technology experts continue to advance our understanding of giant squid. As new methods emerge, such as autonomous underwater vehicles and improved deep-sea imaging systems, scientists hope to unravel more mysteries surrounding these fascinating creatures of the deep. The oceans harbor a wealth of mysterious creatures that could have fueled ancient tales of sea monsters like the kraken. One prime candidate is the giant squid, a creature that can grow up to 43 feet in length. These elusive beings dwell in the ocean depths and were only first captured on film in their natural habitat in 2004. Their massive size, long tentacles, and rarely seen nature make them a perfect inspiration for tales of monstrous sea creatures. Another contender is the colossal squid, which is even larger and heavier than its giant cousin. With eyes the size of dinner plates and sharp hooks on its tentacles, the colossal squid embodies the terrifying aspects often attributed to mythical sea monsters. These creatures inhabit the deep waters of the Antarctic and have been known to battle with sperm whales, leaving scars that early sailors might have mistaken for signs of epic battles with legendary beasts. The giant oarfish is yet another deep-sea dweller that could have inspired kraken-like legends. These serpentine fish can grow up to 36 feet long and have a distinctive red dorsal fin that runs the length of their bodies. When they occasionally wash up on shores or are spotted near the surface, their snake-like appearance and immense size could easily be mistaken for a sea serpent or other mythical creature. Lastly, large species of octopus, such as the giant Pacific octopus, might have contributed to these legends. Their intelligence, ability to change color and texture, and their tentacled form align closely with descriptions of the kraken. While not as large as the squid species mentioned, their appearance near the surface and shorelines made them more likely to be encountered by sailors and coastal dwellers, potentially sparking tales of tentacled monsters from the deep. Giant squid inhabit the deep, dark waters of all the world's oceans, thriving in the cold depths between 200 and 1,000 meters below the surface. These elusive creatures, which can grow up to 13 meters in length, have long captured human imagination but have rarely been observed in their natural habitat. Scientists have pieced together information about giant squid behavior through limited sightings and the study of specimens washed ashore or found in the stomachs of sperm whales, their primary predators. Giant squid are believed to be solitary hunters, using their two long tentacles to snatch prey such as fish and other squid. Their large eyes, which can reach the size of dinner plates, are thought to help them detect the faint bioluminescence of potential prey in the darkness of the deep sea. Recent advancements in deep-sea exploration technology have allowed researchers to capture footage of live giant squid in their natural environment. These rare observations have revealed that giant squid move through the water with surprising grace, propelling themselves using jet propulsion and fine adjustments of their fins. Their habitat appears to be characterized by near total darkness, intense pressure, and temperatures close to freezing. Despite these breakthroughs, much about the giant squid remains a mystery. Scientists are still working to understand their life cycle, mating habits, and population distribution. The challenges of studying such a deep-dwelling creature ensure that the giant squid continues to be one of the most enigmatic and fascinating inhabitants of our oceans. Our knowledge of giant squid has grown tremendously over the past 100 years, transforming these elusive creatures from mythical sea monsters into fascinating subjects of scientific study. In the early 20th century, giant squid were known primarily through rare, often decomposed specimens washed ashore or found in the stomachs of sperm whales. These incomplete and damaged remains left much to the imagination, fueling wild speculations about their size and behavior. As marine biology advanced, scientists began piecing together a more accurate picture of giant squid. They discovered that while impressive, these cephalopods were not quite as monstrous as once believed, typically reaching lengths of up to 43 feet, including their long feeding tentacles. Researchers also learned about their deep-sea habitat, realizing that giant squid primarily inhabit the dark, cold waters of the ocean's middle depths. A major breakthrough came in 2004 when Japanese scientists captured the first images of a live giant squid in its natural habitat. This momentous event was followed by more footage and even a live specimen briefly brought to the surface in 2012. These encounters revolutionized our understanding, revealing the squid's true colors, movement patterns, and behavior. Today, we continue to unravel the mysteries of giant squid through advanced technologies like deep-sea submersibles and environmental DNA sampling. Scientists are now studying their ecology, life cycle, and potential vulnerability to climate change and ocean acidification. While many questions remain, our view of giant squid has evolved from fearsome monsters to magnificent, yet fragile denizens of the deep, worthy of our curiosity and conservation efforts. Throughout maritime history, several submarine disappearances have captured public attention and sparked intense speculation. One of the most well-known cases is the vanishing of the USS Scorpion in 1968. This nuclear submarine mysteriously disappeared in the Atlantic Ocean with 99 crew members on board. Despite extensive search efforts, the wreckage was not discovered until several months later, and the exact cause of its sinking remains a subject of debate to this day. Another famous incident occurred in 2017 when the Argentine submarine ARA San Juan went missing with 44 sailors aboard. After a year-long search involving multiple nations, the wreckage was finally located in the South Atlantic. The loss of the San Juan highlighted the dangers that submariners face even in modern times. Going back further in history, the disappearance of the French submarine Minerve in 1968 off the coast of Toulon remains one of the most perplexing cases. With 52 crew members lost, the Minerve vanished without a trace and was only found in 2019, bringing closure to families after more than 5 decades of uncertainty. These submarine disappearances serve as somber reminders of the risks involved in undersea operations and the immense challenges of search and recovery missions in the vast, deep oceans. They continue to fascinate the public and drive improvements in submarine safety and technology. Modern submarines are technological marvels compared to their predecessors. Today's submarines are larger, faster, and can dive much deeper than those from the past. They are equipped with advanced sonar systems, allowing them to detect objects and other vessels from great distances. Nuclear power has revolutionized submarine capabilities, enabling them to remain submerged for months at a time without surfacing. The submarines that disappeared in the past often fell victim to technical failures, navigational errors, or enemy attacks. Many lacked the sophisticated safety systems found in modern vessels. Today's submarines have multiple backup systems, emergency protocols, and advanced life support systems to protect their crews. Communication technology has also greatly improved. Modern submarines can maintain constant contact with their bases using satellite communications and other advanced systems. This is a far cry from the limited radio capabilities of earlier submarines, which often led to their disappearance without a trace. Lastly, modern submarines benefit from improved hull designs and materials, making them more resistant to pressure at extreme depths. They also have advanced rescue capabilities, including escape pods and systems to help locate the vessel in case of an emergency. These advancements have significantly reduced the likelihood of submarines disappearing without explanation, as happened more frequently in the past. Searching for lost submarines presents a host of formidable challenges that test the limits of our technology and human ingenuity. The vast expanse of the ocean, with its crushing depths and pitch-black darkness, creates an environment that is inherently hostile to exploration. One of the primary obstacles is the sheer size of the search area. Oceans cover more than 70% of our planet's surface, and a submarine could potentially be anywhere within this enormous volume of water. Narrowing down the search zone requires piecing together often limited and unreliable information about the submarine's last known position, its intended course, and any distress signals or debris that may have been detected. The extreme pressure at ocean depths poses another significant hurdle. As we descend into the abyss, the weight of the water column above increases dramatically. At the deepest parts of the ocean, this pressure can exceed 1,000 atmospheres, severely limiting the types of equipment that can function in such conditions. Specialized deep-sea vehicles and sensors must be engineered to withstand these crushing forces while maintaining their operational capabilities. Communication and visibility pose additional challenges. Radio waves do not penetrate water well, making it difficult to maintain contact with search vessels and equipment. Sonar becomes the primary tool for detection, but its effectiveness can be hampered by varying water temperatures, salinity levels, and underwater terrain. Visual searches are equally problematic, as natural light disappears rapidly with depth, necessitating powerful artificial lighting systems that can only illuminate small areas at a time. Submarine search and rescue technology has made remarkable strides since the early days of undersea exploration. In the past, when a submarine encountered trouble, the chances of rescue were slim. Today, advanced systems and international cooperation have significantly improved the odds of survival for submariners in distress. Modern submarine rescue vehicles are sophisticated machines capable of operating at great depths. These submersibles can dock with disabled submarines, even in challenging conditions. They are equipped with advanced life support systems, allowing them to sustain crew members during complex rescue operations. Additionally, atmospheric diving suits enable rescuers to work outside the vehicle in extreme pressure environments. Sonar technology has also played a crucial role in enhancing search capabilities. Contemporary sonar systems can detect and locate submarines with unprecedented accuracy, even in vast ocean expanses. This improvement has drastically reduced search times, a critical factor when every moment counts in a rescue scenario. Perhaps one of the most significant advancements has been the development of international rescue protocols and cooperation. Nations worldwide now participate in joint exercises and share resources, ensuring a swift and coordinated response to submarine emergencies, regardless of location or nationality. Submarine disappearances have been a concern for navies worldwide since the advent of underwater vessels. While each incident is unique, some patterns have emerged over time. Early submarine losses were often due to technical failures or design flaws, as navies were still perfecting this new technology. During World War II, combat-related disappearances peaked, with many submarines lost to depth charges, naval mines, or enemy vessels. In the post-war era, a shift occurred. Peacetime losses became rarer but still significant. The United States Navy experienced notable disappearances with the USS Thresher in 1963 and the USS Scorpion in 1968. These incidents led to major safety overhauls in submarine design and operation procedures. Soviet and Russian submarine losses have shown a pattern of nuclear submarine incidents, particularly in the 1980s and 90s. The sinking of the Kursk in 2000 highlighted ongoing challenges in submarine safety and rescue operations. Modern submarine disappearances are extremely rare, thanks to technological advancements and stringent safety protocols. However, when they do occur, they often involve smaller navies with less advanced equipment or maintenance procedures. The tragic loss of the Indonesian submarine KRI Nanggala in 2021 underscores that even with progress, the deep sea remains a challenging environment for submarine operations. Ocean currents and underwater terrain are critical factors in submarine operations and can significantly contribute to accidents. Strong currents can push submarines off course or make it challenging to maintain precise positioning, especially during delicate maneuvers near coastal areas or in narrow passages. These powerful water movements can exert tremendous force on a submarine, potentially causing collisions with underwater obstacles or other vessels if not carefully managed. Underwater terrain poses its own set of challenges. Seamounts, underwater canyons, and abrupt changes in depth can create complex navigational environments. Submarines must constantly monitor their surroundings using sonar and other sensing equipment to avoid collisions with these underwater features. In areas with rugged seafloor topography, the risk of grounding or striking submerged obstacles increases substantially. The interaction between currents and underwater terrain can create additional hazards. When water flows over irregular seafloor features, it can generate unpredictable eddies, vortices, and turbulence. These hydrodynamic phenomena can affect a submarine's stability and maneuverability, potentially leading to loss of control in extreme cases. Furthermore, underwater landslides or sudden shifts in seafloor sediment, often triggered by seismic activity, can create unexpected obstacles or changes in water density that may impact submarine operations. Accurate mapping and real-time monitoring of ocean currents and underwater terrain are essential for safe submarine navigation. Despite technological advancements, the vast and dynamic nature of the ocean environment means that unexpected conditions can still arise, underscoring the ongoing importance of skilled crew members and robust safety protocols in preventing submarine accidents. Investigating the final moments of a lost submarine involves a complex process that combines advanced technology, forensic analysis, and expert knowledge. Oceanographers and naval experts use sonar systems to scan the seafloor, searching for any signs of wreckage. Once located, remotely operated vehicles equipped with high-definition cameras are deployed to capture detailed images of the submarine and surrounding debris field. Investigators meticulously examine these visual records, looking for clues such as hull damage, scattered equipment, or signs of internal explosions. They also analyze data from nearby seismic sensors, which might have detected any underwater disturbances at the time of the incident. This information helps reconstruct the sequence of events leading to the submarine's loss. Recovering the vessel's black box, if possible, provides crucial information about the submarine's final hours. These devices record various parameters such as depth, speed, and internal conditions. Experts also study oceanographic data, including water currents and temperature, to understand the environment the submarine was operating in. Ultimately, investigators combine all this evidence with their knowledge of submarine operations and potential failure modes. They consider factors like mechanical malfunctions, human error, or external threats to form a comprehensive picture of the submarine's last moments. This painstaking process not only helps bring closure to families, but also contributes to improving submarine safety for future missions. Submarine disappearances have profoundly influenced naval policies and procedures worldwide, leading to significant changes in safety protocols and operational practices. These tragic events have forced navies to reevaluate and enhance their submarine safety measures, communication systems, and emergency response capabilities. One of the most notable impacts has been the implementation of more rigorous maintenance and inspection routines. Navies now conduct more frequent and thorough checks of submarine systems, particularly those critical for life support and navigation. This heightened vigilance aims to identify and address potential issues before they escalate into life-threatening situations. Communication protocols have also undergone substantial revisions. Submarines are now required to make regular contact with their base, and any unexpected loss of communication triggers immediate search and rescue operations. Advanced tracking systems have been developed to monitor submarine locations more accurately, allowing for quicker responses in emergencies. Furthermore, submarine crew training has intensified, with a greater emphasis on emergency procedures and survival techniques. Navies have invested in sophisticated simulation technologies to prepare submariners for a wide range of potential crises, ensuring they can react swiftly and effectively in high-pressure situations. These comprehensive changes reflect the naval community's commitment to preventing future tragedies and protecting the lives of those who serve beneath the waves. The mysterious vanishing of submarines continues to intrigue maritime experts and the public alike. One of the most perplexing cases is the disappearance of the French submarine Minerve in 1968. Despite extensive search efforts at the time and renewed attempts in recent years, the exact cause of its loss remained unknown for decades until its wreckage was finally discovered in 2019. However, questions still linger about the precise sequence of events that led to its sinking. Another baffling case is the fate of the Argentine submarine ARA San Juan, which disappeared in 2017. While its wreckage was located a year later, the reason for its sinking remains a topic of debate among experts. Theories range from mechanical failures to explosive events, but a definitive explanation has yet to be established. The vanishing of the Indonesian submarine KRI Nanggala in 2021 also puzzled experts initially. Although the wreckage was found shortly after its disappearance, the exact circumstances leading to its sinking are still being investigated. These cases highlight the challenges of submarine operations and the difficulties in determining causes when disasters occur in the depths of the ocean. Submarine crews undergo rigorous and comprehensive training to prepare for a wide range of potential emergencies. Safety is paramount in the confined and isolated environment of a submarine, where even minor incidents can quickly escalate into life-threatening situations. Crew members participate in frequent drills that simulate various emergency scenarios, such as fires, flooding, toxic gas leaks, and equipment failures. These exercises hone their skills and reflexes, ensuring they can respond swiftly and effectively when every second counts. Teams practice damage control techniques, including sealing off compartments, operating emergency equipment, and coordinating evacuation procedures. Submariners also receive extensive cross-training, allowing them to perform multiple roles if needed during a crisis. This versatility is crucial in situations where certain crew members might be incapacitated or unable to reach their stations. Additionally, crews are trained in advanced first aid and medical procedures to handle injuries or illnesses that may occur during long deployments. Psychological preparation is equally important. Submariners learn to manage stress, maintain clear communication, and work cohesively as a team under extreme pressure. This mental resilience is vital for surviving prolonged emergencies and making critical decisions in life or death situations. Ocean lights have long fascinated mariners and scientists alike, with several well-documented cases capturing the imagination of researchers worldwide. One of the most famous instances is the Bermuda Triangle lights, reported by numerous ships and aircraft over the years. These unexplained glowing phenomena often appear as bright, pulsating orbs that seem to dance on the water's surface or hover just above it. Another intriguing case is the Marfa lights in Texas, which, although not strictly oceanic, share similar characteristics with marine light phenomena. Observers describe these as colorful, basketball-sized spheres that move erratically across the horizon. While some attribute them to atmospheric conditions or car headlights, their true nature remains a mystery. The Bay of Bengal in the Indian Ocean has also been the site of numerous light sightings. Fishermen and sailors report seeing glowing wheels of light that appear to spin beneath the waves. These bioluminescent displays are often attributed to colonies of marine organisms, but their exact cause is still debated among experts. Perhaps the most scientifically studied case is that of the Milky Seas phenomenon. This rare occurrence, documented by sailors for centuries, involves vast stretches of ocean glowing with a steady, white light. Satellite observations have confirmed these events, with one notable case in the Indian Ocean covering an area roughly the size of Connecticut. While bioluminescent bacteria are the likely culprit, the specific conditions that trigger such large-scale events remain a subject of ongoing research. Unexplained ocean lights present a fascinating mystery that continues to intrigue scientists and observers alike. Unlike the well-understood phenomenon of bioluminescence, which is produced by living organisms through a chemical reaction, these enigmatic lights often defy conventional explanations. Bioluminescence typically appears as a soft, blue-green glow that can be seen in waves, wakes, or surrounding marine life. It is predictable, occurring in specific regions and seasons, and is often triggered by movement or disturbance in the water. In contrast, unexplained ocean lights can manifest in various colors, including bright, white, red, or orange, and may appear as intense flashes or sustained glows that move in seemingly intelligent patterns. These mysterious lights have been reported to emerge from great depths, sometimes hovering above the water surface, and occasionally even ascending into the sky. Unlike bioluminescence, which is confined to the water, these phenomena can exhibit behavior that appears to defy natural explanations, leading to speculation about their origin and nature. While some instances of unexplained ocean lights might be attributed to rare atmospheric events, underwater volcanic activity, or undiscovered marine life, many cases remain perplexing. Scientists continue to investigate these occurrences, using advanced technology and interdisciplinary approaches to unravel the secrets behind these captivating and elusive illuminations in our vast oceans. Unexplained ocean lights have intrigued scientists and sailors for centuries. Several scientific explanations have been proposed to account for these mysterious illuminations. One of the most common explanations is bioluminescence, a natural phenomenon where living organisms produce and emit light. Certain species of plankton, jellyfish, and fish can create dazzling displays of light in the water, sometimes covering vast areas of the ocean surface. Another proposed explanation involves the presence of methane gas. Underwater methane deposits can sometimes escape from the sea floor, creating bubbles that rise to the surface. These bubbles might interact with bioluminescent organisms or reflect light in ways that create unusual visual effects on the water's surface. Some scientists have suggested that electrical phenomena could be responsible for certain unexplained ocean lights. Electrical discharges in the atmosphere, similar to lightning but occurring at sea level, might produce brief flashes or glowing areas on the water. This theory is still being investigated, as the exact mechanisms for such discharges over open water are not fully understood. Lastly, some researchers propose that certain unexplained ocean lights might be the result of human activity. Oil rigs, submarines, or other vessels could potentially create unusual light patterns on the water under specific conditions. However, this explanation does not account for all reported sightings, especially those from remote areas or historical accounts predating modern technology. Ocean light sightings have long fascinated mariners and scientists alike, often intertwining with other maritime mysteries. These enigmatic illuminations, sometimes called marine bioluminescence, have been reported in various forms across the world's oceans. While many of these sightings can be attributed to natural phenomena, some remain unexplained and contribute to the broader tapestry of oceanic enigmas. One intriguing correlation exists between ocean light sightings and reports of unidentified submerged objects. Sailors have described witnessing strange lights moving beneath the water's surface, sometimes accompanied by large, fast-moving shapes. These accounts bear similarities to descriptions of alleged underwater vehicles or unknown marine creatures, blurring the lines between natural phenomena and unexplained occurrences. Another connection lies between ocean lights and electromagnetic anomalies. Some researchers have noted that areas known for frequent light sightings also exhibit unusual electromagnetic readings. This has led to speculation about potential links between these lights and other mysterious events, such as compass malfunctions and electronic equipment failures at sea. Interestingly, Regions famous for ocean light sightings often overlap with areas associated with ship and aircraft disappearances. The Bermuda Triangle, for instance, is known for both its reported light phenomena and unexplained vanishings. While no definitive link has been established, these coincidences continue to fuel speculation and scientific inquiry into the nature of these maritime mysteries. Sailors and fishermen have long reported mysterious lights in the ocean, sparking curiosity and sometimes fear. These unexplained phenomena, often called marine bioluminescence or sea sparkle, can create an eerie glow in the water that seems to defy explanation. Many experienced mariners approach these lights with a mix of wonder and caution. Some interpret them as signs of good fortune, believing they indicate abundant fish in the area. Others view them more warily, associating the lights with old seafaring legends of ghost ships or supernatural events. Scientists explain that most of these lights are caused by tiny marine organisms called dinoflagellates. These microscopic creatures emit light when disturbed, creating a beautiful blue glow in the water. However, not all ocean lights can be attributed to bioluminescence. Sailors have also reported strange, moving lights that seem to follow their ships or appear and disappear rapidly. In response to these unexplained lights, sailors and fishermen often document their observations, sharing their experiences with fellow mariners and researchers. Some adjust their routes to avoid areas where unusual lights are frequently seen, while others actively seek out these phenomena for further study or simply to witness their beauty. Regardless of their interpretation, these mysterious ocean lights continue to captivate those who spend their lives at sea, reminding us of the many wonders and mysteries that still exist in our oceans. Oceanographers employ a range of sophisticated tools to investigate unusual light phenomena in the ocean depths. Specialized underwater cameras, equipped with high-sensitivity sensors, capture bioluminescent displays and other faint light emissions. These cameras often feature low-light amplification technology to detect even the dimmest glows in the darkest reaches of the sea. Submersible vehicles, both manned and remotely operated, carry an array of instruments for close-up observations. These include spectrometers that analyze the wavelengths of light emitted by marine organisms or unusual phenomena, helping scientists identify the chemical processes behind the illumination. Photomultiplier tubes, extremely sensitive light detectors, are also utilized to measure the intensity and duration of light pulses in the water. For broader surveys, autonomous underwater vehicles equipped with bioluminescent sensors traverse vast areas of the ocean, mapping out regions of heightened light activity. These robots can operate for extended periods, providing valuable data on the distribution and frequency of light phenomena across different marine environments. Additionally, satellite-based instruments monitor large-scale bioluminescent events visible from space, such as massive algal blooms that can illuminate vast stretches of the ocean surface. This multifaceted approach allows researchers to study unusual light phenomena from the microscopic to the global scale, unraveling the mysteries of the ocean's living light. Throughout maritime history, sailors have reported mysterious lights appearing on the ocean surface. These phenomena, often called sea lights or marine phosphorescence, have been documented in ship logs and sailors' tales for centuries. One of the most famous historical accounts comes from Christopher Columbus during his first voyage to the Americas in 1492. He described seeing a strange light in the water, which he interpreted as a good omen for his journey. Many other explorers and naval officers have recorded similar sightings. Captain James Cook noted bioluminescent displays in his journals during his voyages in the 18th century. He described the sea as being filled with luminous spots caused by marine animals. In the 19th century, Charles Darwin observed this phenomenon during his voyage on the HMS Beagle, noting how the ship seemed to sail through a sea of milk. These historical accounts often attributed the lights to supernatural causes or unknown sea creatures. Sailors sometimes believed the lights were souls of the dead or mythical beings like mermaids. In some cultures, these lights were seen as warnings of impending storms or shipwrecks. The folklore surrounding ocean lights has been a rich source of maritime superstitions and legends. Today, we know that most of these sightings can be explained by bioluminescent marine organisms such as dinoflagellates or jellyfish. However, the historical accounts of ocean lights continue to fascinate us, offering a glimpse into how our ancestors interpreted the mysterious phenomena of the sea. Researchers employ a variety of techniques to differentiate between natural, artificial, and unexplained light sources in marine environments. For natural phenomena, scientists look for characteristic patterns and behaviors. Bioluminescence, for instance, often appears as a soft, blue-green glow that can be triggered by movement in the water. These living light sources might flash briefly or create sustained illumination depending on the species involved. Man-made lights typically have distinct qualities that set them apart. Artificial sources often emit steady, bright light with specific colors, such as the white or yellow beams from ships or offshore platforms. These lights usually maintain a constant intensity and may move in predictable patterns, following shipping lanes or remaining stationary at known locations. Unexplained light sources present a greater challenge. Researchers carefully analyze the behavior, color, intensity, and duration of these anomalous lights. They use advanced imaging equipment and spectral analysis to gather detailed data. By comparing these observations with known phenomena, scientists can often rule out common explanations. However, some cases remain puzzling, prompting further investigation and sometimes sparking debates within the scientific community. To ensure accuracy, researchers cross-reference their observations with maritime traffic data, weather reports, and information about undersea geological activity. This comprehensive approach helps eliminate potential sources of confusion and allows scientists to focus on truly unexplained phenomena, advancing our understanding of marine environments and the mysteries they hold. Atmospheric conditions play a crucial role in how we perceive ocean lights, particularly those produced by bioluminescent organisms. The clarity of the air, humidity levels, and the presence of particles or pollutants can all affect our ability to see these mesmerizing displays. On clear nights with low humidity, the light from bioluminescent plankton or other marine organisms can be more visible from the shore or from boats. This is because there are fewer water droplets or particles in the air to scatter or absorb the light. However, when the atmosphere is hazy or filled with moisture, the light from these organisms can appear diffused or muted, making the spectacle less vibrant to observers. Moonlight also influences our perception of ocean lights. During a full moon, the bright ambient light can overpower the subtle glow of bioluminescence, making it harder to see. Conversely, on a moonless night, the darkness allows the ocean lights to stand out more prominently, creating a more dramatic visual effect. Air pollution can have a significant impact on the visibility of ocean lights. Particulate matter and other pollutants in the atmosphere can scatter and absorb light, reducing the clarity and intensity of the bioluminescent display. This is one reason why these natural light shows are often more impressive in remote, unpolluted areas compared to coastal regions near urban centers. Scientists are indeed actively investigating unexplained ocean light phenomena, with several research projects currently underway. One of the most intriguing areas of study focuses on bioluminescent milky seas, vast expanses of glowing ocean that can stretch for thousands of square kilometers. These rare events have been reported by sailors for centuries, but have only recently been captured by satellite imagery. Researchers are using a combination of satellite observations, ship-based measurements, and laboratory experiments to unravel the mysteries behind these massive light shows. They are particularly interested in understanding the environmental conditions that trigger such events and the specific organisms responsible for producing the light. Another area of ongoing research involves mysterious flashes of light observed in the deep ocean. Scientists, using specialized cameras on submersibles, have recorded brief, intense bursts of light in areas where bioluminescence was previously unknown. These observations have led to new questions about undiscovered light-producing organisms and potential non-biological sources of light in the deep sea. Additionally, oceanographers are studying the phenomenon of red tides, algal blooms that can produce eerie nighttime displays of blue-green light along coastlines. While the general mechanism of this bioluminescence is understood, researchers are investigating how climate change and human activities might be altering the frequency and intensity of these events. The megalodon was a colossal prehistoric shark that once roamed the ancient oceans. This formidable predator dwarfed even the largest modern great white sharks, reaching lengths of up to 60 feet. With jaws powerful enough to crush a car and teeth the size of human hands, the megalodon was the apex predator of its time. Fossil evidence suggests that the megalodon lived during the Miocene and Pliocene epochs, emerging about 23 million years ago. This massive shark dominated the seas for millions of years, feeding on large marine mammals such as whales and seals. However, the reign of the megalodon came to an end approximately 3.6 million years ago during the Pliocene epoch. The exact reasons for its extinction are still debated among scientists, but several factors likely contributed. These include climate change, which led to cooling oceans and the loss of warm water breeding areas, as well as the decline of its prey species. The disappearance of the megalodon had a significant impact on marine ecosystems, altering predator-prey relationships and allowing other species to fill the ecological niche it once occupied. While the megalodon no longer swims in our oceans, its legacy continues to captivate scientists and the public alike, offering a glimpse into the incredible diversity of life that has existed on our planet throughout its long history. Despite popular speculation, there is no credible scientific evidence supporting the continued existence of megalodon in our oceans today. This massive prehistoric shark, which lived approximately 23 million to 3.6 million years ago, is well documented in the fossil record, primarily through its enormous teeth. However, all reliable data indicates that megalodon went extinct millions of years ago. The ocean is vast and largely unexplored, which has led some to suggest that megalodon could still lurk in the depths. However, several factors contradict this notion. First, no modern megalodon teeth have ever been found. Given that sharks continuously shed and replace their teeth throughout their lives, the absence of recent megalodon teeth is telling. Additionally, there have been no confirmed sightings or captures of megalodon in modern times. Furthermore, megalodon required a specific ecosystem and food supply to sustain its massive size. The changing climate at the end of the Pliocene epoch altered ocean currents and temperatures, likely contributing to megalodon's extinction by disrupting its food sources. Today's oceans could not support a population of these enormous predators without leaving noticeable evidence of their presence. While the idea of megalodon still existing captures the imagination, it remains firmly in the realm of cryptozoology rather than scientific fact. The evidence we have points to megalodon as an extinct species, reminding us of the incredible diversity of life that has existed on our planet throughout its long history. Cryptozoologists examining the megalodon question face a challenging task. These researchers, who study animals whose existence is unproven, approach the possibility of living megalodons with a mix of skepticism and curiosity. They analyze reported sightings, investigate potential evidence, and consider the ecological requirements for such a massive predator to survive in modern oceans. One key aspect of their approach involves scrutinizing the fossil record. Megalodons, known scientifically as Otodus megalodon, were enormous shark species that lived millions of years ago. Cryptozoologists examine the most recent megalodon fossils, dating back to about 3 million years ago, to understand when these creatures might have gone extinct and whether there is any possibility of survival. Another important element of their research involves analyzing modern shark populations and ocean ecosystems. They consider whether the current marine environment could support a predator of megalodon size, estimated to have reached lengths of up to 60 feet. This includes assessing available food sources, potential habitats, and the likelihood of such a large animal remaining undetected by modern technology. Cryptozoologists also evaluate eyewitness accounts and alleged evidence, such as unusually large tooth marks on whale carcasses or oversized shark teeth found by deep-sea explorers. While maintaining scientific rigor, they remain open to the slim possibility that a remnant population might exist in unexplored ocean depths. However, most mainstream scientists consider the existence of living megalodons highly improbable given the lack of concrete evidence and the significant challenges such a large predator would face in the modern ocean. Mainstream marine biologists firmly reject the notion that megalodon, the prehistoric giant shark, still exists in our oceans today. These experts point to several key factors that make megalodon survival extremely unlikely. Firstly, the fossil record clearly shows that megalodon went extinct approximately 3 million years ago. No megalodon remains have been found in deposits younger than this date, which is a strong indicator of its extinction. Additionally, if such a large predator were still alive, it would leave evidence of its existence through things like distinctive bite marks on large marine animals or teeth lost during feeding. Marine biologists also emphasize that the ocean ecosystem has changed dramatically since megalodon's time. The giant whales that likely formed a significant part of its diet are now much less abundant, and the cooling of the oceans would have made survival challenging for a warm water species like megalodon. Furthermore, scientists argue that it would be nearly impossible for such a large animal to remain undetected in today's heavily monitored and explored oceans. With advanced sonar technology, extensive shipping routes, and comprehensive marine surveys, the presence of a massive shark species would almost certainly have been documented by now. The megalodon was a true giant of the prehistoric seas, dwarfing even the largest modern sharks. This ancient predator, which lived approximately 23 million to 3.6 million years ago, reached staggering proportions that are difficult to fathom. Scientists estimate that the megalodon could grow up to 60 feet in length, making it roughly 3 times the size of the largest great white sharks we see today. To put this into perspective, imagine a shark nearly the length of a bowling lane with a mouth wide enough to swallow a small car hole. In contrast, the largest living shark species, the whale shark, typically reaches lengths of about 40 feet. However, whale sharks are filter feeders, not predators like the megalodon. The largest predatory shark alive today, the great white, usually maxes out at around 20 feet in length, with the largest confirmed specimen measuring just over 23 feet. The sheer size difference between the megalodon and modern sharks is a testament to the dramatic changes in marine ecosystems over millions of years. The extinction of this massive predator likely had significant impacts on ocean food chains and the evolution of other marine species, including the ancestors of our modern sharks. The existence of megalodon in today's oceans would dramatically alter marine ecosystems worldwide. This enormous prehistoric shark, measuring up to 60 feet in length, would require vast quantities of food to sustain itself. Its diet would likely consist of large marine mammals such as whales, seals, and sea lions, as well as other sharks and large fish. The presence of megalodon would significantly impact whale populations, potentially leading to a reduction in their numbers. This could have far-reaching consequences for ocean ecosystems, as many whale species play crucial roles in nutrient cycling and maintaining the balance of marine food webs. The reduced whale population could also affect the availability of food for other predators and scavengers. Megalodon would compete with existing apex predators like great white sharks and orcas for food resources. This competition could lead to changes in the behavior and distribution of these modern predators, potentially pushing them into new habitats or altering their hunting strategies. The presence of megalodon might also influence the evolution and behavior of its prey species, possibly leading to new adaptations for escape and survival. Furthermore, the existence of megalodon would likely have significant implications for human activities in the ocean. Commercial fishing, marine transportation, and coastal tourism could all be affected by the presence of this massive predator. Scientists would also have a unique opportunity to study this prehistoric species in its natural habitat, potentially gaining new insights into ancient marine ecosystems and the evolution of large marine predators. The megalodon, an extinct species of shark that lived millions of years ago, has made a significant impact on popular culture and media. This massive prehistoric predator has captured the imagination of people worldwide, appearing in various forms of entertainment and sparking public interest in paleontology and marine biology. In literature, the megalodon has been featured in numerous novels, particularly in the thriller and science fiction genres. Authors have often depicted it as a terrifying creature that has somehow survived to the present day, creating suspenseful narratives that blend fact with fiction. These books have helped popularize the megalodon and fueled public fascination with the idea of ancient marine predators. The film industry has also embraced the megalodon, with several movies featuring the giant shark as a central element. Perhaps the most notable example is the 2018 film The Meg, which brought the creature to life through computer-generated imagery and presented it as a formidable threat to modern humans. This movie, along with others in the genre, has introduced the megalodon to a broader audience and reinforced its status as an icon of prehistoric terror. Television documentaries and educational programs have frequently highlighted the megalodon, exploring its size, hunting habits, and eventual extinction. These shows have played a crucial role in disseminating scientific information about the species to the general public, while also speculating about its potential survival in unexplored parts of the ocean. This blend of factual content and imaginative speculation has kept the megalodon firmly in the public consciousness, inspiring both fear and fascination with the ancient oceans and their inhabitants. Scientists employ various techniques to investigate the possibility of living megalodons, though the scientific consensus firmly holds that these giant sharks went extinct millions of years ago. Marine biologists conduct extensive ocean surveys, using sonar and underwater cameras to scan vast areas of the deep sea. These methods have successfully discovered other large marine species, but have yielded no evidence of megalodon. Researchers also analyze recent shark tooth fossils and compare them with ancient megalodon teeth. The absence of any megalodon teeth in recent geological layers strongly suggests their extinction. Additionally, scientists study ocean ecosystems and food chains, recognizing that a predator as large as megalodon would leave noticeable impacts on marine populations. Satellite technology and tracking of large marine animals provide further insights. If megalodons existed today, their massive size would likely make them detectable from space, much like how we observe whales. The lack of any such sightings supports the conclusion that megalodons no longer inhabit our oceans. Despite these efforts, the search for megalodon often ventures into the realm of cryptozoology, where less rigorous methods are sometimes employed. However, the scientific community remains focused on evidence-based approaches, continuing to explore our oceans while acknowledging that the likelihood of finding a living megalodon is extremely low. Megalodon teeth offer paleontologists a wealth of information about this ancient super-predator. These massive fossilized teeth, some reaching lengths of over 7 inches, serve as crucial clues to understanding the sheer size and predatory behavior of megalodon. By examining the size and shape of megalodon teeth, scientists can estimate the overall length of the shark. Using comparisons with modern shark species, researchers have determined that megalodon likely reached lengths of up to 60 feet, making it one of the largest predatory fish ever to exist. The serrated edges and robust structure of megalodon teeth indicate a diet consisting of large marine mammals, including whales. These teeth were designed for slicing through tough flesh and breaking bones, suggesting that megalodon was an apex predator capable of taking down enormous prey. Wear patterns on the teeth also provide insights into megalodon feeding behavior. Some teeth show signs of breakage or wear, implying that megalodon engaged in powerful, aggressive attacks on its prey. This evidence, combined with the sheer size of the teeth, paints a picture of a formidable hunter that dominated ancient oceans for millions of years before its extinction. Beyond the famous Loch Ness monster, several other prehistoric marine creatures have captured the imagination of cryptozoologists and the public alike. The megalodon, an enormous prehistoric shark that lived millions of years ago, is often speculated to lurk in the ocean depths, Despite no concrete evidence, some enthusiasts claim sightings of massive shark fins or unusually large bite marks on whales. Another intriguing creature is the plesiosaur, a long-necked marine reptile from the age of dinosaurs. Reports of plesiosaur-like animals have come from various locations, including Lake Champlain in North America, where the creature is affectionately known as champ. Similarly, the ogopogo of Lake Okanagan in Canada is sometimes described as resembling a plesiosaur. The prehistoric fish, known as the coelacanth, was once thought extinct until its rediscovery in 1938. This has fueled speculation about other ancient fish species potentially surviving in unexplored ocean depths. The frilled shark, with its prehistoric appearance, is sometimes mistaken for a living fossil, though it is a known extant species. Lastly, cryptozoologists have proposed the existence of giant squid-like creatures, often linking them to ancient legends of the kraken. While giant squid do exist, some claim that even larger cephalopods, possibly related to prehistoric species, might inhabit the unexplored regions of our oceans, capturing the imagination of those who wonder what other surprises the seas might hold. Sonar technology has revealed numerous fascinating underwater anomalies that continue to captivate scientists and explorers. One of the most intriguing discoveries is the Baltic Sea anomaly, a peculiar formation found in 2011 at the bottom of the Baltic Sea. This structure appears to have straight lines, right angles, and smooth surfaces, leading some to speculate about its artificial origin. Another remarkable find is the Cuban underwater city, discovered off the coast of Cuba in 2001. Sonar images revealed a vast complex of stone structures covering an area of about 2 square kilometers. Some researchers believe these structures could be the remnants of an ancient civilization, although their true nature remains a subject of debate. In the North Sea, sonar has uncovered Doggerland, a submerged landmass that once connected Great Britain to continental Europe. This underwater landscape includes hills, valleys, and even evidence of human habitation, offering a glimpse into a world that existed over 8,000 years ago. Sonar has also revealed mysterious underwater circles off the coast of Denmark. These perfect circles, measuring up to 20 meters in diameter, were later discovered to be created by male pufferfish as part of their mating ritual. This finding demonstrates how sonar technology can lead to unexpected and remarkable discoveries about marine life behavior. Researchers employ a variety of techniques to differentiate between natural formations and potential artificial structures. They begin by examining the geometry and symmetry of the object or structure in question. Natural formations typically exhibit irregular shapes and patterns, while artificial structures often display more uniform, precise, or repetitive features. Detailed analysis of the materials and composition is another crucial step. Scientists use spectroscopy and other advanced imaging techniques to determine the chemical makeup of the structure. Artificial structures might contain elements or compounds that are rare or out of place in the natural environment, while natural formations usually consist of materials commonly found in their surroundings. The context and location of the structure also play a significant role in the assessment. Researchers consider the geological and environmental factors that could have shaped the formation naturally. They look for signs of weathering, erosion, or other natural processes that might explain the structure's existence. In contrast, artificial structures might show evidence of purposeful placement or construction techniques that are inconsistent with natural processes. Lastly, researchers often employ interdisciplinary approaches, combining expertise from fields such as geology, archaeology, and engineering. This collaborative effort helps ensure a comprehensive evaluation, considering multiple perspectives and methodologies to reach a well-informed conclusion about the origin of the structure in question. In 2001, a team of explorers using sonar equipment claimed to have discovered a massive underwater structure off the western coast of Cuba. This structure, they reported, resembled a pyramid and was located at a depth of approximately 2,000 feet. The alleged discovery quickly sparked intense debate and speculation within both scientific and pseudoscientific communities. Proponents of the discovery suggested that this underwater formation could be evidence of an advanced ancient civilization, possibly linked to the legendary lost city of Atlantis. They pointed to the apparent geometric precision of the structure and its massive size as indicators of intelligent design. Some even proposed that it might be older than the Egyptian pyramids, potentially rewriting our understanding of human history. However, many scientists and archaeologists have expressed skepticism about these claims. They argue that the sonar images are inconclusive and that natural geological formations can often resemble artificial structures when viewed through sonar. Critics also point out the lack of follow-up expeditions and clear photographic evidence to support the initial claims. The controversy surrounding the Cuban underwater pyramid highlights the ongoing tension between scientific rigor and the allure of ancient mysteries. While the idea of a submerged ancient city is undoubtedly captivating, the scientific community continues to emphasize the need for verifiable evidence before drawing extraordinary conclusions about our past. Satellite technology has revolutionized our understanding of the ocean floor, unveiling underwater anomalies that were once hidden from view. Advanced sensors aboard satellites can measure subtle variations in sea surface height, which often indicate the presence of underwater features such as seamounts, trenches, or even undiscovered islands. One of the most significant contributions of satellite technology is through gravity mapping. Massive underwater structures exert a gravitational pull that causes slight bulges in the ocean surface. These bulges, though imperceptible to the naked eye, can be detected by satellite altimeters with remarkable precision. This technique has led to the discovery of numerous underwater volcanoes and mountain ranges that were previously unknown. Satellite imagery has also played a crucial role in identifying underwater anomalies. High-resolution optical and radar images can reveal color variations in shallow waters, indicating the presence of coral reefs, underwater vegetation, or even sunken ships. In deeper waters, thermal imaging satellites can detect temperature differences that might suggest hydrothermal vents or cold seeps on the ocean floor. Furthermore, satellites equipped with synthetic aperture radar can penetrate cloud cover and even the top layers of the ocean surface, providing valuable data on underwater topography and potential anomalies. This technology has been instrumental in mapping the seafloor and identifying features such as underwater canyons, ridges, and even potential sites of geological activity. Underwater, linear and geometric formations have sparked curiosity and debate among scientists and explorers. Several explanations have been proposed to account for these intriguing structures found beneath the waves. Natural geological processes offer one potential explanation. Underwater volcanic activity can create long linear formations as lava flows and cools. Tectonic movements might also form straight lines or geometric patterns on the seafloor. Erosion and sedimentation can carve out regular shapes over time, especially in areas with strong currents. Some researchers suggest that certain formations could be the result of ancient human activity. Submerged cities or structures from past civilizations might leave behind geometric patterns. However, these claims are often controversial and require substantial evidence to support them. Biological factors can also contribute to the creation of seemingly organized structures underwater. Coral reefs, for instance, can grow in linear formations along underwater ridges or form circular atolls. Some marine organisms build vast colonies that, from a distance, may appear geometric or deliberately arranged. While the ocean depths have long captivated our imagination, there is currently no conclusive scientific evidence of underwater anomalies that definitively suggest ancient advanced civilizations. However, several intriguing underwater discoveries have sparked debate and speculation among researchers and the public alike. One notable example is the Yonaguni Monument off the coast of Japan. This underwater rock formation features step-like terraces and sharp angles that some argue are too precise to be natural. However, most geologists maintain that these structures are the result of natural erosion and tectonic activity rather than human intervention. Another fascinating site is the submerged city of Pavlopetri off the coast of Greece. Dating back approximately 5,000 years, This Bronze Age settlement provides valuable insights into ancient Mediterranean cultures, but does not indicate technology beyond its time. Similarly, the ruins of ancient Port Royal in Jamaica, submerged by an earthquake in 1692, offer a glimpse into a more recent past rather than an advanced ancient civilization. These underwater sites, while historically significant, have not yielded evidence of technology or knowledge that surpasses our understanding of these ancient cultures. The search for underwater anomalies continues, driven by our curiosity about the past and the vast unexplored regions of our oceans. As we develop more advanced underwater exploration technologies, we may yet uncover new findings that challenge our current understanding of ancient civilizations. Ocean currents and geological processes work together to shape the seafloor in ways that can be surprisingly deceptive. Over millions of years, powerful underwater currents carve intricate patterns into the ocean bed, creating formations that often resemble artificial structures or even lost civilizations. One striking example is the Bimini Road in the Bahamas. This underwater rock formation appears to be a paved road or ancient harbor, leading some to speculate about its origins. However, geologists have determined that it is a natural limestone formation, shaped by erosion and the deposition of sediments over time. In other cases, volcanic activity can create seemingly impossible structures beneath the waves. Underwater volcanoes can form perfectly symmetrical cones or vast networks of tunnels and caves that appear to be the work of intelligent design. The interplay between lava flows and water can also produce pillow lavas, which stack up to create formations that resemble ancient walls or foundations. Tectonic activity further contributes to these deceptive underwater landscapes. As plates shift and collide, they can push up sections of the seafloor, creating underwater mountains, trenches, and plateaus that mimic the layout of sunken cities or long-lost continents. These geological processes, combined with the erosive power of ocean currents, continue to sculpt the underwater world into forms that challenge our perceptions and fuel our imaginations. Amateur researchers have become increasingly important in identifying underwater anomalies, thanks to advancements in technology and the growing accessibility of underwater exploration equipment. These citizen scientists often bring fresh perspectives and enthusiasm to the field, complementing the work of professional marine biologists and oceanographers. Many amateur researchers use relatively affordable sonar equipment and underwater drones to scan coastal areas and lakes, sometimes stumbling upon unexpected findings. These discoveries can range from previously unknown shipwrecks to unusual geological formations or even unidentified marine species. Their efforts have led to significant contributions in mapping underwater terrain and identifying potential sites for further scientific investigation. One of the most valuable aspects of amateur involvement is the sheer number of eyes and ears they bring to the task. Professional research teams are often limited by time and resources, but amateur enthusiasts can cover vast areas over extended periods. This increased coverage has resulted in the discovery of numerous underwater anomalies that might otherwise have gone unnoticed. Collaboration between amateur researchers and professional scientists has also proven fruitful. Many academic institutions and research organizations now have programs that allow citizen scientists to submit their findings for expert analysis. This partnership has not only expanded our understanding of underwater environments, but has also fostered a greater public interest in marine science and conservation efforts. Scientists employ a range of techniques to investigate claims of mysterious underwater structures. The process begins with thorough research of existing geological and historical data to understand the context of the area in question. This background information helps determine if the alleged structure could be a natural formation or if human involvement is plausible. Remote sensing technologies play a crucial role in initial investigations. Sonar mapping and satellite imagery provide detailed views of the seafloor, allowing scientists to identify unusual shapes or patterns without the need for costly expeditions. These methods can often reveal if a structure is likely to be natural or artificial. When remote sensing suggests further investigation is warranted, scientists conduct on-site surveys. Underwater vehicles equipped with high-resolution cameras and sensors gather detailed visual and physical data. Divers may also collect samples for analysis, looking for signs of artificial construction or natural geological processes. Interdisciplinary collaboration is key in these investigations. Geologists examine rock formations and sediment patterns. Marine biologists study the interaction between the structure and local ecosystems, and archaeologists assess any potential cultural significance. By combining multiple lines of evidence, scientists can build a comprehensive understanding of the structure's origin and nature, either verifying its mysterious status or providing a natural explanation. Underwater anomalies have revolutionized our understanding of marine geology, revealing a hidden world of geological wonders beneath the waves. These discoveries have shed light on the dynamic processes shaping our planet's seafloor and provided crucial insights into Earth's geological history. One of the most significant impacts has been the discovery of hydrothermal vents. These underwater geysers, first found in the late 1970s, have completely altered our perception of life in extreme environments. They have shown us that entire ecosystems can thrive in the absence of sunlight, relying instead on chemosynthesis. This finding has expanded our understanding of where life can exist, both on Earth and potentially on other planets. Underwater volcanoes and seamounts have also played a crucial role in advancing marine geology. These submerged mountains, often rising thousands of meters from the seafloor, have provided valuable information about plate tectonics and the formation of oceanic crust. They have helped geologists map the movement of tectonic plates and understand the processes driving seafloor spreading. The discovery of vast underwater canyons and trenches has further expanded our knowledge of marine landscapes. These features, such as the Mariana Trench, have allowed scientists to study the deepest parts of our oceans and gain insights into the Earth's crust and mantle. They have also revealed new species adapted to extreme pressure and darkness, pushing the boundaries of our understanding of life on Earth. Maritime time slips are a fascinating phenomenon reported by sailors and ship crews throughout history. These unusual occurrences involve ships seemingly traveling through time, either to the past or future, for brief periods. Witnesses describe finding themselves in unfamiliar surroundings, encountering vessels from different eras, or experiencing temporal displacement. Reports of maritime time slips often share common elements. Crew members might suddenly notice changes in their environment, such as different weather conditions, unfamiliar landmarks, or the appearance of ships that seem out of place. In some cases, instruments and navigation equipment may malfunction or display inconsistent readings. The experience typically lasts for a short duration before the ship and its crew return to their original time and location. One of the most famous alleged maritime time-slip incidents occurred in 1911 when the SS Marlborough reported encountering the Mary Celeste, a ship that had been found abandoned at sea nearly 40 years earlier. The crew of the Marlborough claimed to have seen and communicated with the Mary Celeste before it vanished into the mist. While skeptics argue that these reports can be attributed to hallucinations, misidentification, or elaborate hoaxes, believers suggest that certain areas of the ocean may have unique properties that allow for temporary breaches in the fabric of time. The mysterious nature of these events continues to captivate the imagination of both maritime enthusiasts and those intrigued by the possibility of time travel. Throughout maritime history, sailors have reported numerous unexplained phenomena at sea, but well-documented cases of temporal anomalies are rare. One intriguing incident occurred in 1911 aboard the ship Siberian. The crew claimed to have experienced a strange time slip, arriving at their destination several days earlier than expected. Despite their insistence, skeptics argue this could be attributed to navigation errors or faulty timekeeping. Another notable case is the Philadelphia experiment, allegedly conducted by the United States Navy in 1943. While not strictly a sailor's experience, this controversial event supposedly involved the warship USS Eldridge becoming invisible and teleporting. Some crew members reported experiencing time distortions, but the veracity of these claims remains heavily disputed. More recently, cruise ship passengers have occasionally reported losing or gaining time inexplicably during their voyages. However, These accounts often lack the rigorous documentation needed for scientific scrutiny. Many experts attribute such experiences to the disorienting nature of being at sea, where the usual markers of time can become distorted. While these cases capture the imagination, the scientific community generally views them with skepticism. The lack of consistent, verifiable evidence makes it difficult to distinguish between genuine temporal anomalies and misperceptions or misreported events. Nevertheless, these stories continue to intrigue both maritime enthusiasts and those fascinated by the mysteries of time. Scientists have investigated numerous reports of time distortions experienced by sailors and maritime workers at sea. These unusual temporal phenomena often involve crew members perceiving time passing differently than expected or encountering inexplicable gaps in their memory. While some cases remain unexplained, researchers have identified several potential factors that could contribute to these experiences. One significant element is the impact of isolation and monotony on human perception. Extended periods at sea with limited external stimuli can alter our sense of time, making hours or days seem to blur together. The brain, deprived of its usual time markers like sunrise and sunset, may struggle to accurately track the passage of time. This effect can be amplified by irregular sleep patterns and shift work common in maritime professions. Environmental factors also play a role in these temporal anomalies. The constant motion of the sea, changes in atmospheric pressure, and exposure to varying levels of oxygen can affect cognitive function and perception. Some scientists suggest that electromagnetic anomalies in certain ocean regions might influence brain activity, potentially leading to altered time perception or memory formation. Psychological stress and fatigue are additional contributors to reported time distortions. The demanding nature of seafaring work, combined with the potential dangers of ocean travel, can induce states of heightened alertness or anxiety. These mental states can skew our perception of time, making dangerous or stressful situations seem to unfold in slow motion, while uneventful periods pass quickly. While many of these explanations are grounded in known psychological and physiological processes, scientists continue to study more unusual reports to uncover potential new insights into the nature of human time perception. Isolation and sensory deprivation can significantly alter our perception of time, leading to what many experience as time anomalies. When deprived of external stimuli and regular environmental cues, the human brain struggles to maintain its usual timekeeping mechanisms. In these conditions, the mind often loses its anchor to the normal passage of time. Minutes can feel like hours, and hours can seem to fly by in an instant. This distortion occurs because our brain relies heavily on external cues and regular patterns of activity to gauge the flow of time. Without these references, our internal clock becomes unreliable. Research has shown that extended periods of isolation can even lead to more extreme time perception distortions. Some individuals report experiencing temporal disorientation, where they lose track of days or even weeks. This phenomenon is particularly notable in extreme environments like space missions or long-term cave explorations. Interestingly, these time anomalies can offer valuable insights into how our brains process temporal information. Scientists study these effects to better understand the neural mechanisms behind time perception and to explore potential applications in fields ranging from psychology to space exploration. Reported maritime time slips, while fascinating to consider, are not scientifically verified phenomena. However, anecdotal accounts of these experiences tend to cluster around certain areas that have long been associated with mysterious occurrences at sea. The Bermuda Triangle, located in the western part of the North Atlantic Ocean, is perhaps the most famous region linked to unusual maritime events, including alleged time slips. Other areas that feature prominently in time-slip reports include the North Sea, particularly off the coast of England and Scotland, and parts of the Mediterranean Sea. The waters around Japan, especially the Dragon's Triangle or Devil's Sea, have also been cited in some accounts. These geographical patterns often coincide with regions that have a rich maritime history and a tradition of seafaring lore. It is important to note that these patterns likely reflect cultural and historical factors rather than any scientifically observable anomalies. Areas with a long history of maritime activity and storytelling traditions are more likely to generate and perpetuate such accounts. Additionally, heavily trafficked shipping routes naturally see more incidents of all kinds, potentially contributing to a higher number of unusual reports. While these geographical patterns in reported timeslips are intriguing, they remain in the realm of folklore and unverified personal accounts rather than established scientific fact. The clustering of reports in certain areas may tell us more about human psychology and cultural narratives than about any actual distortions in time or space. Timeslip accounts in maritime settings have intrigued researchers and sailors alike for centuries. Modern reports of time slips at sea often involve advanced technology and more precise measurements, allowing for detailed documentation of these anomalous events. Ships equipped with GPS systems and atomic clocks can detect even slight discrepancies in time, leading to more accurate and verifiable reports. Historical maritime timeslip accounts, on the other hand, relied heavily on personal observations and less precise timekeeping methods. Sailors in the past used celestial navigation and mechanical chronometers, which were susceptible to errors due to environmental factors and human miscalculation. This lack of precision often resulted in more ambiguous and subjective descriptions of time anomalies. Another key difference lies in the cultural and scientific context surrounding these reports. Historical accounts were often intertwined with superstition and folklore, attributing time slips to supernatural causes or divine intervention. Modern reports tend to be viewed through a more scientific lens, with researchers exploring potential explanations rooted in physics and our understanding of space-time. The frequency and distribution of timeslip reports also differ between modern and historical accounts. Historical reports were more sporadic and localized, often associated with specific maritime routes or regions. Modern accounts, while still rare, are more widely distributed and can be correlated with global positioning data, weather patterns, and other measurable factors. This shift in reporting and analysis has led to a more systematic approach in studying these fascinating temporal anomalies at sea. The human mind's perception of time can be significantly altered when at sea, leading to what many sailors and maritime explorers have described as time anomalies. These experiences are rooted in various psychological factors that come into play in the unique environment of vast oceans. One key factor is the lack of familiar time markers. On land, our daily routines are often structured around external cues like sunrise, sunset, mealtimes, and work schedules. At sea, especially during long voyages, these markers can become less distinct. The endless expanse of water and sky can create a sense of timelessness, making it difficult for the brain to track the passage of hours or even days. Isolation and sensory deprivation also play crucial roles. The limited stimuli at sea, compared to the constant barrage of information on land, can cause the brain to process time differently. This reduced sensory input can lead to a phenomenon known as time dilation, where time seems to stretch or contract unpredictably. Some individuals report that days seem to blur together, while others experience moments that appear to last much longer than usual. Additionally, the rhythmic motion of waves and the constant sound of water can induce a meditative state, further altering time perception. This, combined with potential disruptions to sleep patterns due to shift work or unusual schedules, can contribute to a sense of time distortion. The psychological impact of being disconnected from the usual flow of information and social interactions on land can also influence how individuals experience the passage of time, potentially leading to these reported time anomalies at sea. Navigational errors and equipment malfunctions play a significant role in many reported timeslip incidents. These technical issues can create confusion and disorientation, leading to experiences that some interpret as unexplained temporal anomalies. For instance, global positioning system glitches or compass malfunctions might cause travelers to become lost, resulting in arrival times that seem impossible based on their perceived journey duration. This discrepancy between expected and actual travel time can give the impression of lost or gained time, fueling speculation about temporal distortions. Similarly, clock or watch malfunctions can directly contribute to time slip reports. If a timepiece suddenly jumps forward or backward or stops working altogether, it can create the illusion of missing time or temporal displacement. This is especially true in isolated areas where external time references are limited. Moreover, navigational mistakes can lead people into unfamiliar territories where disorientation and stress might alter their perception of time passing. Combined with equipment failures, these factors can create a perfect storm of confusion that some individuals interpret as a paranormal time slip experience rather than a more mundane explanation rooted in human error and technological shortcomings. Maritime time slips, though not scientifically proven, share intriguing parallels with other reported paranormal experiences. These mysterious events, where sailors claim to have briefly traveled through time while at sea, echo elements found in various unexplained phenomena. One notable similarity is the sudden and unexpected nature of these experiences. Much like reported ghost sightings or UFO encounters, witnesses often describe a sense of disorientation and confusion, feelings commonly associated with many paranormal events. The temporary nature of maritime time slips also mirrors the fleeting quality of other supernatural occurrences. Another parallel lies in the alteration of perceived reality. Just as people who report seeing ghosts describe a world momentarily different from our own, sailors experiencing time slips claim to witness landscapes, technologies, or cultures from another era. This distortion of the familiar environment is a recurring theme in many paranormal accounts. The skepticism and debate surrounding maritime time slips also echo the controversies of other paranormal phenomena. Like Bigfoot sightings or telepathic experiences, time slips face scrutiny from the scientific community, yet continue to captivate the public imagination. This persistence in popular culture, despite lack of concrete evidence, is a common thread among many unexplained events. The widespread adoption of global positioning system technology and highly accurate atomic clocks has significantly impacted reports of time anomalies at sea. In the past, sailors often relied on less precise methods of navigation and timekeeping, which could lead to discrepancies and unexplained phenomena. Modern GPS systems provide incredibly precise location data, allowing ships to determine their position with accuracy down to a few meters. This level of precision has largely eliminated navigation errors that might have previously been attributed to mysterious time slips or spatial anomalies. Additionally, the synchronization of clocks across the globe using atomic time standards has made it much easier to track and verify the passage of time accurately, even in remote ocean locations. As a result, many of the time anomalies reported by sailors in earlier eras can now be explained by factors such as equipment errors, misreadings of instruments, or natural phenomena like unusual currents or weather patterns. The improved accuracy and reliability of modern navigation and timekeeping systems have effectively reduced the number of credible reports of unexplained time discrepancies at sea. However, this technological advancement has not completely eliminated all reports of unusual temporal experiences. Some individuals still claim to encounter inexplicable time shifts or disorientation while at sea, prompting ongoing scientific investigation into these phenomena and their potential causes. The ocean depths harbor a symphony of mysterious sounds that have puzzled scientists for decades. One of the most enigmatic is the bloop, a powerful ultra-low frequency sound detected in 1997. Initially thought to be of biological origin, it was later attributed to icequakes, but its exact nature remains debated. Another perplexing sound is the Julia, a screeching noise recorded in the equatorial Pacific. Its origin is unknown, with theories ranging from underwater volcanic activity to unidentified marine life. The upsweep, a series of narrowband sounds that rise in frequency, has been detected since 1991 and continues to baffle researchers. The slowdown, recorded in the eastern equatorial Pacific Ocean, is characterized by a descending tone lasting about 7 minutes. Its source remains unidentified, adding to the ocean's acoustic mysteries. The whistle, a high-pitched sound detected near the Antarctic Peninsula, is another unexplained phenomenon that has captured scientists' attention. These enigmatic ocean sounds highlight how much we have yet to discover about our planet's underwater realm. They serve as reminders of the ocean's vastness and complexity, inspiring continued exploration and research into the hidden world beneath the waves. Scientists employ a range of sophisticated techniques to distinguish between biological, geological, and unexplained ocean sounds. Advanced hydrophones and sonar systems capture these underwater audio signals, which are then analyzed using spectrograms and other visual representations of sound waves. Biological sounds often have distinct patterns and frequencies associated with specific marine life. For instance, whale vocalizations typically fall within a recognizable range, while the clicks of dolphins and the grunts of fish have their own unique acoustic signatures. These biological sounds tend to have more variation and complexity compared to geological noises. Geological sounds, on the other hand, are usually more consistent and predictable. Underwater earthquakes, volcanic eruptions, and ice movements produce characteristic rumbles and creaks that scientists can identify based on their frequency, duration, and intensity. These sounds often correlate with seismic data and known geological events, making them easier to classify. Unexplained ocean sounds present the greatest challenge for scientists. These mysterious noises, like the famous bloop or Julia signals, don't fit neatly into biological or geological categories. Researchers carefully analyze these anomalous sounds, comparing them to known sources and considering potential explanations. Sometimes, what initially seems unexplainable is later attributed to natural phenomena or human activity, while other sounds remain enigmatic, fueling continued scientific investigation and speculation about their origins. The upsweep sound remains one of the most intriguing and unexplained phenomena in ocean acoustics. First detected by underwater microphones in the Pacific Ocean in 1991, this mysterious sound continues to puzzle scientists and spark curiosity among researchers and the public alike. Characterized by a long, continuous series of rising tones, the upsweep sound occurred several times per minute, gradually increasing in frequency over about 7 minutes. It was heard throughout the Pacific, with the strongest signals originating from a remote area in the South Pacific. What makes upsweep particularly fascinating is its seasonal pattern, becoming more pronounced during spring and autumn. Despite years of study, the exact cause of upsweep remains unknown. Scientists have proposed several theories, including volcanic activity on the seafloor, the movement of massive ice sheets, or even the presence of large marine creatures. However, none of these explanations fully account for the sound's unique characteristics and seasonal variations. The upsweep sound has diminished in intensity since its discovery, but it can still be detected to this day. Its persistence and mysterious nature continue to drive scientific inquiry, reminding us that our oceans still hold many secrets waiting to be uncovered. The ongoing investigation into upsweep highlights the importance of underwater acoustic monitoring in understanding our planet's complex oceanic processes. Underwater microphones, known as hydrophones, are sophisticated devices designed to capture and record sounds in aquatic environments. These specialized instruments convert acoustic waves traveling through water into electrical signals, allowing scientists to listen to and analyze the rich symphony of ocean life and geological processes. Hydrophones are typically constructed with piezoelectric materials that respond to changes in pressure caused by sound waves. As these waves pass through the water and reach the hydrophone, they cause the piezoelectric element to vibrate. These vibrations are then converted into electrical signals that can be amplified, recorded, and analyzed. The captured sounds are processed using advanced signal analysis techniques. Scientists employ various methods such as spectral analysis, which breaks down complex sounds into their component frequencies, and pattern recognition algorithms to identify specific marine species or events. These tools allow researchers to distinguish between different types of sounds, from the haunting songs of whales to the crackling of melting icebergs. Hydrophones have revolutionized our understanding of marine ecosystems and ocean dynamics. They enable scientists to monitor marine mammal migrations, study underwater seismic activity, detect illegal fishing operations, and even track the effects of climate change on ocean soundscapes. By providing a window into the normally hidden auditory world beneath the waves, hydrophones have become invaluable tools in marine research and conservation efforts. The 52 Hz whale, often called the loneliest whale in the world, has puzzled scientists since its unique call was first detected in 1989. Several theories attempt to explain the origin of this mysterious sound. One prominent idea suggests that the whale could be a hybrid between two different species, possibly a blue whale and a fin whale. This interbreeding might have resulted in a creature with an atypical vocal structure, producing a call unlike any known whale species. Another theory proposes that the 52 Hz whale might be a malformed individual of a known species, possibly with a deformity in its vocal cords or air sacs. This physical anomaly could explain why its call is at a much higher frequency than other whales of its presumed type. Some researchers have also speculated that the sound could be coming from a previously undiscovered species of whale, although this is considered less likely given our extensive knowledge of large marine mammals. A more recent hypothesis suggests that the whale might not be alone or unique at all. Instead, it could be part of a small population of whales that all share this distinctive call. The rarity of the 52 Hz sound could be due to the small number of individuals rather than a single anomalous whale. Some scientists have even proposed that the sound might not be coming from a whale at all, but from some other unidentified source in the ocean. Despite years of research and numerous expeditions, the true identity of the 52 Hz whale remains elusive. The mystery surrounding this creature continues to captivate both scientists and the public, highlighting how much we still have to learn about the vast and complex ecosystems of our oceans. Human activities have a significant impact on the underwater soundscape, creating challenges for scientists studying ocean acoustics. The increasing noise pollution in our oceans stems from various sources, including shipping traffic, offshore construction, seismic surveys for oil and gas exploration, and military sonar operations. Large cargo ships and tankers produce low-frequency rumbles that can travel for hundreds of kilometers, masking the natural sounds of marine life and potentially interfering with their communication and navigation. These persistent background noises make it difficult for researchers to isolate and study the vocalizations of whales, dolphins, and other marine species. Offshore construction, particularly for wind farms and oil platforms, generates intense sounds that can disrupt marine ecosystems and complicate acoustic research. The loud, repetitive noises from pile driving and drilling operations can overwhelm recording equipment and obscure more subtle natural sounds. Similarly, seismic surveys using air guns produce powerful sound waves that can interfere with both marine life and scientific recordings over vast areas. Military activities, including the use of active sonar systems, add another layer of complexity to ocean acoustics. These intense, manufactured sounds can travel long distances and potentially cause behavioral changes in marine animals, further complicating the interpretation of acoustic data. As human activities in the oceans continue to increase, scientists must develop more sophisticated methods to filter out anthropogenic noise and accurately interpret the natural acoustic environment of the seas. The vast depths of our oceans hold many secrets, and mysterious sounds have long intrigued scientists and explorers alike. These enigmatic noises often correlate with other maritime phenomena, creating a complex tapestry of oceanic mysteries. One notable correlation exists between unexplained ocean sounds and underwater volcanic activity. The famous bloop sound, recorded in the southern Pacific Ocean, was initially thought to be of biological origin. However, further research revealed its likely source to be the cracking of ice shelves or underwater volcanic eruptions. This connection highlights the intricate relationship between geologic processes and acoustic phenomena in the ocean. Mysterious ocean sounds have also been linked to the behavior of marine life, particularly during unusual migration patterns or feeding events. The upsweep sound, A series of narrow-band, upsweeping sounds detected in the Pacific coincides with seasonal changes in whale migration routes. Some researchers speculate that these sounds might be related to massive gatherings of marine life drawn to areas of increased food availability due to oceanic upwelling. Furthermore, some unexplained ocean noises correlate with extreme weather events and climate phenomena. The whistle sound, heard in the Caribbean Sea, has been associated with pressure changes caused by tropical storms and hurricanes. This connection between atmospheric conditions and underwater acoustics demonstrates the complex interplay between different aspects of our planet's systems, reminding us of the interconnectedness of Earth's various phenomena. Unusual ocean sounds offer tantalizing clues about undiscovered marine life, opening up a world of possibilities beneath the waves. The oceans are vast and largely unexplored, with many areas remaining untouched by human observation. In these mysterious depths, strange noises captured by underwater microphones hint at the existence of creatures we have yet to encounter. One intriguing example is the bloop, an ultra-low frequency sound detected in the southern Pacific Ocean in 1997. Initially thought to be of biological origin due to its organic-sounding nature, it was later attributed to ice quakes. However, this event highlighted how little we know about the sounds produced by deep-sea creatures and the potential for misinterpretation. Marine biologists and oceanographers continue to record and analyze unusual ocean sounds, hoping to identify new species or behaviors. Some of these noises could be produced by undiscovered whale species, giant squid, or even unknown forms of marine life adapted to the extreme pressures of the deep ocean. By studying these acoustic signatures, scientists can gain insights into the size, behavior, and distribution of elusive creatures without directly observing them. The discovery of new vocalizations also raises questions about the complexity of marine communication systems. As we uncover more about these mysterious sounds, we may find that the underwater world is filled with intricate languages and social structures we never imagined existed. This acoustic exploration of the oceans not only expands our knowledge of marine life, but also reminds us of the vast unknowns still waiting to be discovered in Earth's aquatic realm. Our understanding of ocean acoustics has grown significantly in recent years, revealing a complex underwater world of sound. Scientists have discovered that the ocean is far from silent, filled with a diverse array of natural and human-made noises that travel vast distances. One major advancement has been the development of sophisticated hydrophone networks, allowing researchers to eavesdrop on marine life and track underwater events across entire ocean basins. These systems have revealed previously unknown whale vocalizations and mapped the migration patterns of various species based on their calls. Researchers have also gained a deeper understanding of how sound propagates through water, influenced by factors such as temperature, pressure, and salinity. This knowledge has led to improved sonar technologies and more accurate climate models, as sound can be used to measure ocean temperatures over large areas. Perhaps most surprisingly, scientists have found that human activities are dramatically altering the ocean's soundscape. Shipping noise, offshore construction, and seismic surveys are creating an underwater cacophony that impacts marine life, affecting everything from whale communication to the behavior of tiny zooplankton. This realization has spurred efforts to monitor and mitigate ocean noise pollution, marking a new frontier in marine conservation. Scientists around the world are actively investigating enigmatic sounds from the depths of our oceans. One prominent project is the Comprehensive Nuclear Test Ban Treaty Organization's hydroacoustic monitoring system. This network of underwater microphones, originally designed to detect nuclear tests, has become an invaluable tool for marine researchers studying unexplained ocean noises. The National Oceanic and Atmospheric Administration conducts ongoing research into unidentified marine sounds. Their scientists analyze recordings of strange noises like the famous bloop and upsweep to determine their origins. These efforts involve advanced signal processing techniques and collaboration with marine biologists to identify potential biological sources. Another significant endeavor is the International Quiet Ocean Experiment. This global research initiative aims to study ocean soundscapes and how human activities affect marine life. As part of their work, they investigate unusual sounds that could be linked to undiscovered species or geological phenomena. Universities worldwide are also contributing to this field. For instance, Oregon State University's Hatfield Marine Science Center runs a project using autonomous underwater vehicles equipped with hydrophones to record and analyze mysterious deep-sea sounds. These efforts combine cutting-edge technology with marine biology expertise to unravel the secrets hidden in the ocean's acoustic landscape. Throughout history, several islands have reportedly vanished, capturing the imagination of explorers and cartographers alike. One of the most well-known cases is the mysterious Bermeja Island, once believed to be located in the Gulf of Mexico. This phantom island appeared on maps for centuries but was nowhere to be found when modern searches were conducted. Its disappearance has sparked debates about whether it ever existed or if it was simply a cartographic error. Another intriguing case is that of Sandy Island, supposedly situated between Australia and New Caledonia. This island was included on maps and nautical charts for over a century, even appearing on Google Earth. However, when scientists went to investigate in 2012, they found nothing but open ocean. The discovery of its non-existence led to its prompt removal from maps and databases. The legendary island of High Brazil, said to lie off the west coast of Ireland, is another famous example. Featured in maps from the 14th to the 19th centuries, this mythical land was described as a paradise hidden by mist. Despite numerous expeditions, no concrete evidence of its existence has ever been found, leading many to conclude it was purely a product of Celtic folklore. These cases of vanishing islands highlight the complexities of early cartography and navigation. They remind us that even in our modern age of satellite imagery and advanced technology, the world can still hold mysteries and surprises. Whether these islands disappeared due to rising sea levels, seismic activity, or were simply mapping errors, their stories continue to fascinate and perplex us. Cartographic errors have played a significant role in perpetuating the myth of vanishing islands throughout history. These mistakes, often made by early explorers and mapmakers, have led to the belief that certain islands have mysteriously disappeared or sunk beneath the waves. One of the primary causes of these errors is the inherent difficulty in accurately mapping remote and isolated locations, especially in the vast expanse of the ocean. Early navigators relied on rudimentary tools and techniques, which sometimes resulted in inaccurate coordinates or misidentified landmasses. As a result, islands might be recorded in the wrong location or confused with other nearby landforms. Another factor contributing to the myth is the phenomenon of transient islands. These are temporary landmasses formed by volcanic activity or accumulated sediment, which may appear and disappear over time. Explorers who encountered these fleeting islands might have recorded them on maps, only for subsequent voyagers to find no trace of them, fueling speculation about vanishing lands. Furthermore, the misinterpretation of natural phenomena, such as fog banks, icebergs, or even large floating masses of pumice, has led to the recording of non-existent islands. When later expeditions failed to locate these phantom landmasses, it reinforced the notion of mysterious disappearances. These cartographic errors, combined with the human tendency to seek explanations for the unexplained, have contributed significantly to the enduring myth of vanishing islands in our collective imagination. Rising sea levels pose a significant threat to small islands worldwide, gradually eroding their coastlines and submerging low-lying areas. As global temperatures increase due to climate change, polar ice caps and glaciers melt at accelerated rates, causing ocean waters to expand and sea levels to rise. This process directly impacts small islands, particularly those with minimal elevation above sea level. The effects of rising seas on small islands are multifaceted. Coastal erosion intensifies as higher water levels and stronger waves batter shorelines, washing away beaches and damaging vital ecosystems like mangroves and coral reefs. These natural barriers typically protect islands from storm surges and further erosion, so their loss compounds the problem. Saltwater intrusion is another consequence of rising seas. As ocean water seeps into freshwater aquifers, it contaminates drinking water supplies and renders agricultural land infertile. This forces island communities to rely more heavily on imported resources, straining local economies and traditional ways of life. In extreme cases, entire islands may become uninhabitable or completely submerged. Some low-lying island nations, such as the Maldives and Tuvalu, face the very real possibility of total submersion within the coming decades if current trends continue. This looming threat has sparked discussions about climate refugees and the need for international cooperation to address the challenges faced by vulnerable island communities. Volcanic activity has indeed caused islands to appear and vanish throughout Earth's history. One of the most famous examples is the island of Surtsey, which emerged off the coast of Iceland in 1963. Over the course of several months, underwater volcanic eruptions built up enough material to break the ocean's surface, creating a new island that remains to this day. On the flip side, the island of Krakatoa in Indonesia provides a dramatic example of an island disappearing. In 1883, a massive volcanic eruption destroyed most of the island, leaving only small remnants behind. However, continued volcanic activity has since created a new island in its place, known as Anak Krakatau, or Child of Krakatoa. More recently, in 2015, a submarine volcano near Tonga in the South Pacific created a new island. This island, unofficially named Hunga Tonga Hunga Hapai, grew to over 120 hectares in size. However, its existence was short-lived. In January 2022, the same volcano erupted again, causing most of the island to disappear beneath the waves. These events demonstrate the dynamic nature of our planet's geology. Volcanic activity continues to shape Earth's surface, creating and destroying landmasses in a constant cycle of change that has persisted for millions of years. Maritime boundary disputes often intersect with the intriguing phenomenon of vanishing or phantom islands in complex and surprising ways. These elusive landmasses, which may appear on maps but not exist in reality, can significantly impact territorial claims and international maritime law. Phantom islands sometimes arise from navigational errors or misidentifications by early explorers. In other cases, they may be the result of deliberate fabrication for political or economic gain. Regardless of their origin, these non-existent islands can become the basis for expansive maritime claims, leading to disputes between nations over resource-rich waters and exclusive economic zones. When a country bases its maritime boundaries on the presence of a phantom island, it can lead to conflicts with neighboring nations. As modern surveying techniques and satellite imagery reveal the true nature of these supposed landmasses, countries may be forced to redraw their maritime borders, potentially losing access to valuable fishing grounds, mineral deposits, or strategic military positions. The resolution of these disputes often requires extensive diplomatic negotiations and sometimes international arbitration. The outcome can have significant economic and geopolitical consequences, highlighting the importance of accurate cartography and the ongoing need for clear, internationally recognized standards in maritime boundary delineation. Vanishing islands pose significant challenges for navigation and maritime safety in our ever-changing oceans. These disappearing landmasses, often victims of rising sea levels and erosion, create a mismatch between nautical charts and the actual maritime landscape. Ships relying on outdated maps might unexpectedly encounter submerged hazards where islands once stood, increasing the risk of running aground or colliding with hidden obstacles. The loss of these islands also affects traditional navigation methods used by local communities. For centuries, Pacific Islanders have relied on their knowledge of island chains and ocean currents for safe passage. As familiar landmarks vanish beneath the waves, this ancestral wisdom becomes less reliable, potentially endangering those who depend on it. Furthermore, vanishing islands can alter ocean currents and wave patterns in their vicinity. These changes might be subtle but can have far-reaching effects on maritime routes, fishing grounds, and even weather patterns. Ships and boats that once found shelter near these islands during storms may now find themselves exposed to harsher conditions. Coastal nations face additional concerns as shrinking islands affect territorial waters and exclusive economic zones. The disappearance of even small, uninhabited islands can lead to significant changes in maritime boundaries, potentially sparking disputes over fishing rights and natural resources. This evolving geography demands constant updates to nautical charts and navigation systems, highlighting the need for ongoing monitoring and international cooperation to ensure safe passage through our dynamic oceans. Verifying the existence of reported islands involves a combination of modern technology and traditional exploration methods. Satellite imagery plays a crucial role in this process, allowing researchers to scan vast areas of ocean from space. These high-resolution images can reveal land masses, coral reefs, and even underwater features that might indicate the presence of an island. However, satellite data alone is not always sufficient. In some cases, researchers conduct field expeditions to physically locate and document reported islands. These trips often involve marine geologists, cartographers, and other experts who use advanced navigation equipment and sonar technology to map the ocean floor and confirm the presence or absence of land. Historical records and maps also play a significant role in island verification. Researchers compare modern data with old charts and accounts from explorers, looking for discrepancies or corroborating evidence. Sometimes, islands that appeared on old maps turn out to be errors, misidentifications, or even deliberate fabrications. The process of verifying islands is ongoing, as changes in sea level, tectonic activity, and erosion can alter coastlines and even submerge small islands over time. Conversely, volcanic activity can create new islands. This dynamic nature of our planet's geography means that the work of confirming and mapping islands is a continuous effort, blending cutting-edge technology with boots-on-the-ground exploration. Vanishing islands have captured human imagination across cultures, spawning numerous legends and myths. In Greek mythology, the island of Atlantis, described by Plato, was said to have sunk into the ocean after falling out of favor with the gods. This tale of a lost, advanced civilization has inspired countless stories and theories throughout history. Pacific Island cultures have their own versions of vanishing islands. Hawaiians tell of Kanehunamoku, a floating island paradise that appears and disappears at will. Only those deemed worthy can find and visit this mystical place. Similarly, in Polynesian lore, the island of Hiva is believed to surface periodically, allowing only the purest souls to set foot on its shores. Celtic folklore speaks of High Brazil, a phantom island shrouded in mist off the coast of Ireland. Legend claims it becomes visible only once every 7 years. Many expeditions sought this elusive land, with some maps even marking its supposed location well into the 19th century. In Japanese mythology, the tale of Horai tells of an enchanted island inhabited by immortal beings. This celestial island was said to drift on the seas, occasionally revealing itself to fortunate observers before vanishing once again into the mists of legend and time. Satellite technology has revolutionized our ability to track and map small islands, offering unprecedented accuracy and coverage. In the past, cartographers relied on ship-based surveys and aerial photography, which were time-consuming, expensive, and often imprecise. Now, high-resolution satellite imagery allows us to observe and map even the tiniest islands and atolls from space. This technology enables us to update maps more frequently, capturing changes in coastlines due to erosion, sea level rise, or natural disasters. For instance, we can now detect new islands formed by volcanic activity or shifting sandbars, as well as monitor the gradual disappearance of low-lying islands threatened by climate change. Satellites equipped with radar systems can penetrate cloud cover and darkness, providing continuous monitoring regardless of weather conditions. This capability is particularly valuable for tracking islands in remote or hazardous areas that are difficult to access by traditional means. Moreover, satellite data helps scientists study the ecosystems of small islands, tracking changes in vegetation, land use, and marine habitats. This information is crucial for conservation efforts and understanding the impacts of human activity and climate change on these often fragile environments. The disappearance of islands has far-reaching ecological consequences that ripple through both marine and terrestrial ecosystems. As sea levels rise due to climate change, many low-lying islands are gradually being submerged, leading to a cascade of environmental impacts. One of the most immediate effects is the loss of critical habitat for numerous plant and animal species. Many islands are biodiversity hotspots, home to unique flora and fauna that have evolved in isolation over millions of years. As these islands vanish, so do the specialized habitats that support these often rare and endemic species, potentially leading to extinctions and a significant reduction in global biodiversity. The loss of islands also disrupts important breeding and nesting grounds for seabirds and marine animals. Many species of birds, sea turtles, and seals rely on these isolated land masses for reproduction. Without these safe havens, their populations may decline rapidly, affecting the delicate balance of marine ecosystems. Furthermore, the submergence of islands alters ocean currents and coastal dynamics, impacting marine life and fisheries. Coral reefs surrounding these islands may struggle to adapt to changing conditions, leading to their degradation and the loss of the diverse communities they support. This, in turn, affects the livelihoods of human populations that depend on these ecosystems for food and economic activities, highlighting the interconnectedness of ecological and human systems in the face of disappearing islands. Rogue waves are monstrous ocean swells that tower above surrounding waves, dwarfing even large ships. These maritime giants are defined by their extreme height and unpredictable nature. A wave is typically classified as rogue when it reaches at least twice the height of the significant wave height, which is the average of the highest third of waves in a given area. Unlike normal ocean waves that form through consistent wind patterns, rogue waves can arise suddenly and seemingly out of nowhere. They often appear in otherwise calm seas, catching sailors and ships off guard. These massive walls of water can reach heights of 30 meters or more, posing a serious threat to maritime safety. The formation of rogue waves involves complex interactions between different wave systems. When waves from various directions or with different wavelengths converge, they can combine their energy to create a single, massive wave. This phenomenon, known as constructive interference, is one of the primary mechanisms behind rogue wave formation. Another key difference is their impact force. While normal waves can be powerful, rogue waves pack an enormously concentrated punch. Their immense size and speed mean they can exert tremendous force on anything in their path, potentially causing catastrophic damage to ships and offshore structures. This combination of size, unpredictability, and destructive power makes rogue waves a fascinating yet terrifying phenomenon of the open ocean. Rogue waves, also known as freak waves or monster waves, were first scientifically acknowledged in the year 1995. This groundbreaking moment occurred when an enormous wave struck the Draupner oil platform in the North Sea off the coast of Norway on New Year's Day. The wave, measuring 84 feet in height, was captured by a downward-facing laser sensor, providing the first reliable scientific evidence of these maritime phenomena. Before this event, rogue waves were largely considered to be nautical folklore, dismissed by many scientists as exaggerations or myths told by sailors. However, the Draupner wave, as it came to be known, forced the scientific community to reconsider their understanding of ocean dynamics and wave formation. This discovery led to increased research into the occurrence and mechanics of rogue waves. Scientists began analyzing historical ship logs, satellite data, and developing new mathematical models to explain and predict these massive, unpredictable waves. The acknowledgement of rogue waves has had significant implications for ship design, maritime safety protocols, and our overall understanding of oceanic behavior. Since the Draupner wave, numerous other rogue waves have been recorded and studied, further validating their existence and importance in the field of oceanography. This scientific acceptance has not only improved maritime safety, but has also opened up new avenues of research in wave dynamics and fluid mechanics. Rogue waves, also known as freak waves, have been the stuff of maritime legend for centuries. These massive, unexpected swells can tower over 60 feet high and pose a significant threat to ships and offshore structures. One of the most well-documented rogue wave incidents occurred in 1995 when the Dropner oil platform in the North Sea recorded a wave measuring 84 feet in height. This event, known as the Dropner wave, provided the first scientific evidence of rogue waves and sparked increased research into the phenomenon. Another notable incident took place in 2001 when two cruise ships, the Bremen and the Caledonian Star, encountered enormous waves in the South Atlantic. The Bremen was struck by a 98-foot wave that smashed windows on the bridge, while the Caledonian Star faced a wave so powerful it damaged the ship's bridge equipment and temporarily knocked out its controls. In 2007, the container ship MSC Napoli was hit by a rogue wave in the English Channel, causing severe structural damage and forcing the crew to abandon ship. The incident led to one of the largest salvage operations in British maritime history. More recently, in 2019, a rogue wave struck the Norwegian cruise ship Viking Sky off the coast of Norway, causing engine failure and prompting a dramatic helicopter evacuation of hundreds of passengers. These incidents have not only captured public imagination, but have also driven scientific efforts to better understand and predict rogue waves, ultimately improving maritime safety for vessels navigating our vast and sometimes treacherous oceans. Rogue waves, also known as freak waves or monster waves, are massive ocean waves that seem to appear out of nowhere. These towering walls of water can reach heights of up to 100 feet, dwarfing even the largest ships and posing a significant threat to maritime safety. Scientists have identified several factors that contribute to the formation of rogue waves. One key mechanism is the phenomenon of wave focusing, where multiple smaller waves converge and combine their energy. This can occur when waves traveling at different speeds and directions intersect, creating a brief but powerful surge of water. Another important factor is the interaction between waves and ocean currents. When waves encounter strong currents flowing in the opposite direction, they can become compressed and amplified, growing to enormous heights. This effect is particularly pronounced in areas with powerful ocean currents, such as the Agulhas, current off the coast of South Africa. Recent research has also highlighted the role of nonlinear wave dynamics in rogue wave formation. Under certain conditions, energy can be transferred from smaller waves to larger ones through a process called modulation instability. This can cause a single wave to grow rapidly, absorbing energy from surrounding waves and becoming a towering rogue wave. Detecting and predicting rogue waves has become increasingly important for maritime safety and offshore operations. Scientists and engineers employ a variety of advanced technologies to tackle this challenge. Satellite altimetry plays a crucial role in monitoring ocean wave patterns over vast areas. These satellites use radar to measure the height of the ocean's surface, allowing researchers to identify unusual wave formations that could potentially develop into rogue waves. Buoy networks scattered across the oceans provide real-time data on wave heights, periods, and directions. These floating sensors transmit information to onshore stations, contributing to our understanding of wave behavior and helping to refine prediction models. In recent years, high-frequency radar systems installed on coastlines have enhanced our ability to detect and track wave patterns as they approach shore. Sophisticated computer models integrate data from these various sources to simulate ocean conditions and predict the likelihood of rogue wave formation. These models take into account factors such as wind patterns, ocean currents, and seafloor topography to create more accurate forecasts. Additionally, machine learning algorithms are being developed to analyze vast amounts of historical and real-time data, improving our ability to identify the precursors of rogue wave events. Onboard ships and offshore platforms, wave radar systems provide real-time monitoring of surrounding sea conditions. These systems can detect approaching large waves, giving crews precious minutes to prepare for potential impacts. As technology continues to advance, our ability to detect and predict rogue waves improves, enhancing safety for those who work and travel on the seas. Rogue waves have significantly impacted ship design and maritime safety regulations, reshaping our approach to ocean travel and naval engineering. These monstrous waves, towering up to 30 meters high, were once dismissed as sailor myths, but are now recognized as real and potentially catastrophic phenomena. The growing understanding of rogue waves has led to crucial changes in ship construction. Modern vessels are built with reinforced hulls and superstructures to withstand the enormous forces these waves can exert. Engineers now factor in the possibility of encountering waves much larger than the average sea state when designing ships, ensuring they can maintain structural integrity under extreme conditions. Maritime safety regulations have also evolved in response to the rogue wave threat. New guidelines require improved weather monitoring systems and enhanced crew training for severe weather scenarios. Ships are now equipped with more sophisticated radar and satellite systems to detect potential rogue wave formations, allowing crews to alter course or prepare for impact. Furthermore, the International Maritime Organization has updated its safety protocols, mandating stricter stability criteria for ships and improved emergency response procedures. These changes aim to minimize the risk of capsizing or structural failure when confronted with these rare but dangerous oceanic events, ultimately enhancing the safety of maritime travel and trade. Rogue waves, also known as freak waves or monster waves, can occur in any ocean basin, but certain areas are indeed more prone to their formation. The North Atlantic Ocean and the waters off the southern coast of South Africa are particularly notorious for these unpredictable and potentially dangerous waves. In the North Atlantic, the area between the Grand Banks off Newfoundland and the southeastern coast of Iceland is known as Rogue Wave Alley. This region experiences a higher frequency of rogue waves due to the convergence of multiple factors. Strong currents, including the Gulf Stream and the Labrador Current, interact with powerful winds and complex seafloor topography, creating conditions that can amplify wave heights and lead to the formation of these massive waves. The Agulhas Current, which flows along the eastern coast of South Africa, is another hotspot for rogue wave activity. As this warm current meets the colder waters of the Southern Ocean, it creates a turbulent mixing zone. This area, combined with strong winds and the unique underwater topography of the continental shelf, increases the likelihood of rogue wave formation. While these regions are more prone to rogue waves, it is important to note that these phenomena can occur in any part of the ocean under the right conditions. Factors such as wind direction, ocean currents, water depth, and the presence of storms or other weather systems all play a role in the development of these extraordinary waves. As our understanding of rogue waves continues to improve, researchers are working on better prediction methods to enhance maritime safety in all ocean regions. Ocean currents and weather patterns are crucial factors in the formation of rogue waves, those monstrous walls of water that can tower up to 100 feet high. These rare and powerful waves result from a complex interplay of oceanic and atmospheric forces. Ocean currents, particularly when they collide or flow against each other, can concentrate wave energy in specific areas. The Gulf Stream, for example, flowing northward along the eastern coast of North America, can interact with southward moving currents, creating turbulent conditions that amplify wave heights. When waves from different directions converge, they can combine their energies, sometimes resulting in a rogue wave that is much larger than the surrounding sea state. Weather patterns also play a significant role in rogue wave formation. Strong winds, especially those associated with intense storms or hurricanes, can generate large waves that travel across vast distances. These waves, known as swell, can interact with local wind-generated waves and currents, potentially leading to the emergence of a rogue wave. Sudden changes in wind direction or speed can cause waves to pile up or focus their energy, further increasing the likelihood of rogue wave occurrence. The phenomenon of wave focusing, where ocean swells are concentrated by underwater topography or bent by currents, can also contribute to rogue wave formation. This effect is particularly pronounced in areas with rapidly changing bathymetry, such as continental shelves or underwater canyons. As waves enter shallower waters, they slow down and increase in height, potentially creating conditions conducive to rogue wave development. Rogue waves, are among the most mysterious and powerful forces in the ocean, towering behemoths that seem to appear out of nowhere. These massive walls of water, sometimes reaching heights of over 30 meters, are distinct from other extreme ocean phenomena in both their formation and impact. Unlike tsunamis, which are triggered by seismic activity or underwater landslides, rogue waves arise from complex interactions of wind, currents, and wave patterns in the open ocean. They can occur even in relatively calm seas, catching mariners off guard with their sudden and localized nature. This unpredictability sets them apart from hurricanes or tropical cyclones, which can be tracked and forecasted days in advance. Rogue waves also differ from storm surges in coastal areas. While storm surges are caused by wind pushing water toward the shore during severe weather events, rogue waves can strike in the middle of the ocean, far from land. Their immense energy and steep faces make them particularly dangerous to ships and offshore structures, capable of causing catastrophic damage in seconds. Scientists are still working to fully understand the mechanisms behind rogue wave formation, but advances in satellite technology and ocean monitoring systems are shedding new light on these elusive giants. As our knowledge grows, so does our ability to predict and potentially mitigate the risks posed by these extraordinary ocean phenomena. Oceanographers and marine scientists are intensifying their efforts to unravel the mysteries of rogue waves, those massive and unpredictable ocean swells that pose significant dangers to ships and offshore structures. Current research focuses on several key areas to improve our understanding and prediction capabilities. Advanced sensor networks are being deployed across the world's oceans to gather more comprehensive data on wave patterns and oceanic conditions. These networks include buoys equipped with state-of-the-art instruments that measure wave heights, wind speeds, and water temperatures with unprecedented accuracy. Satellite technology is also playing a crucial role, with new Earth observation satellites providing detailed imagery and data on ocean surface conditions over vast areas. Computer modeling has become a cornerstone of rogue wave research. Scientists are developing increasingly sophisticated algorithms that simulate ocean dynamics and wave interactions. These models incorporate data from sensors and satellites to create more accurate predictions of where and when rogue waves might form. Machine learning techniques are being applied to analyze vast amounts of historical and real-time data, helping to identify patterns and precursors that may signal the formation of these giant waves. Interdisciplinary collaboration is driving progress in this field. Physicists are working alongside oceanographers to better understand the complex, non-linear dynamics that give rise to rogue waves. Engineers are contributing their expertise to design more resilient ships and offshore structures that can withstand these extreme events. This combined effort aims not only to predict rogue waves, but also to mitigate their potential impacts on maritime safety and infrastructure.